We're halfway through our Power BI course. Welcome to week 3, where things are about to get very technical. This week's lessons will require you to install a sample database on your machine. Known as AdventureWorks, this database is commonly used by companies or schools who want to teach basics about how to interact with data through SQL or SQL. But in this course, we're going to use it to explore how Power BI interacts with databases. So let's start with some background. AdventureWorks is a company, a fictitious one, that sells sports equipment both online and in retail stores, and their database is built to capture all of their product, sales, and financial data. In addition to that, AdventureWorks has a data warehouse, which is a separate database that is used only for reporting and analytics. AdventureWorks loads their data from the main database into the data warehouse, and they give their Power BI developers access to the data warehouse so they can connect and build reports. In this scenario, the data warehouse has already taken care of a lot of the data transformation for us. This is most often how data warehouses are built in the real world. We extract data from a source, transform it into a new structure that is optimized for reporting and analytics, and then we load it into the warehouse. Sounds familiar, right? ETL, like we talked about in week 1. The point is, the data that we're working with in week 3 will involve very little in terms of cleanup and transformation, because that work was already done when the data warehouse was loaded by an ETL process. Instead, we're going to focus on some other aspects of data preparation and modeling. We're going to introduce you to the concept of the star schema, which is a type of data model that is ubiquitous in the world of Power BI, and will almost certainly show up on the Power BI Data Analyst Certification exam if you choose to take it. We'll also talk about how to build DirectQuery reports and how to optimize them. And we'll go deeper into DAX, introducing you to more complex formulas that use time intelligence functions to analyze our data across different dates and times. We'll explore some really cool methods of visualizing both of these types of data in Power BI, as well as other topics like Power BI report security and AI-driven visuals. For learners on the verified track, we have more exclusive interviews this week with Power BI experts, plus some more tips and tricks to help you with your projects. There's a lot of ground to cover in week 3, so let's jump onto my computer and start building some cool stuff. I'll see you there. To complete this week's lessons, you'll need to install SQL Server Express on your machine. I've included a few links below this video. The first takes you to the hardware and software requirements for installing SQL Server, in case you want to refer to those. But the second link will take you to the SQL Server Downloads page, seen here, and you just need to find the Download Now button underneath SQL Server Express. This will download an executable to your computer, which you can then click to run, and that will begin installation. When you're prompted to select an installation type, just choose the Basic option, which will install the database engine in its default configuration, which is all you need in order to complete these lessons. You will accept the license terms, then pick a location on your hard drive where everything will be installed, then click the Install button. The installation process will take a few minutes. Once it's done, you'll get this window letting you know installation completed successfully, and there is some information here you will need to make note of for the future. The instance name of the SQL Server database engine, in my case, is SQL Express. That means the database server I just installed is named SQL Express. To the right of that, you'll see a box labeled Connection String, and within that you can see this little section that says server equals localhost / SQL Express. That localhost / SQL Express string there is vitally important for our lessons, so you need to memorize it or copy and paste it into a file somewhere so that you'll remember it. Next, we need to install SQL Server Management Studio, or SSMS, because this will allow us to install our AdventureWorks sample database. So, click the button at the bottom that says Install SSMS, and that will take you to a new page in your browser where you can find a free download of SSMS. Once the installer is finished downloading, go ahead and launch it. Then click the Install button, and go ahead and run a basic installation of SSMS. This, again, might take a few minutes. Once SSMS is installed, we can close that installer, then return to the SQL Server installer, grab the localhost /SQL Express and copy that. Then we can close the SQL Server installer. And now let's go to our Windows Start menu and search for SQL Server Management Studio and open it up. Once SSMS is open, we can connect to our database by putting the localhost /SQL Express into the server name box here on our connection window. Then click Connect. On the left-hand side of SSMS is a panel called the Object Explorer, which shows all of the servers and databases that we're connected to. Now, there are two types of databases in SQL Server. There are system databases, which are installed automatically on the server and which are not really relevant to this course. And then there are user databases, which are those that are deployed by us, the users. Now, currently, we don't have any user databases deployed to our server, so we're going to right-click on the databases folder and then find the option to Restore Database. Essentially, what we're going to do here is create the database using the file that is contained in the Week 3 folder of our exercise files. This file, named AdventureWorksDW 2022.back, is a database backup file which contains all of the information about the structure of the database as well as all of its data. So we can install a full-fledged database on our SQL Server instance using this one file. One thing that may help the restore database process go a little smoother is to actually take that backup file and copy it to your C drive, like so. Once it's there, we can return to SSMS, select the device option from the Restore Database window, then click this button over to the right. Next, click Add, then navigate to your C drive, and find the file named AdventureWorksDW 2022.back. Hit OK, click OK again, verify the backup media, and then click OK. After a moment, SSMS will tell you that the database AdventureWorksDW 2022 was restored successfully. Then just click OK. Now we can see AdventureWorksDW 2022 available in our Object Explorer. And if we expand, we'll find all of the tables that exist in our database. Now we're ready to connect to this database from Power BI Desktop. I'll see you in the next lesson. Before we connect to our new AdventureWorks data warehouse from Power BI Desktop, let's take a few minutes to introduce one of the most important concepts in business intelligence, dimensional modeling. Dimensional modeling is a methodology that we use in data warehouse design and data modeling in Power BI to define the key processes and entities that make up the data we are looking at. If I'm building a Power BI project to report on retail sales, dimensional modeling requires us to start at the most basic information about the process of retail sales and use that information to determine how the data model should be built. So what happens in retail sales? Well, it depends, but generally the way it works is that on a certain date, a customer goes to a retail location, which could be either a physical location or an online store, and they buy a product from a particular salesperson. To put it another way, if I need to buy a suit, I will pick a day when I'm able to do that. I'll go to the store, find a salesperson, browse for the suit I want and try it on, then make a decision, maybe get it marked up for tailoring, and then I'll pay the salesperson for the suit. In this process, there are several things I'm going to make note of, which I will refer to as entities. The first entity is me, the customer. Then there's the product I want to buy. Then there's the store that sells the product, the salesperson who sold me the product, and the day on which I bought the product. In the world of dimensional modeling, these entities are known as dimensions. These dimensions establish the context around the sale, and the sale itself is known as a fact. It's where all of that context comes together, in this case at a transactional level. The sales transaction of me buying this particular suit from the salesperson at this store on this specific date, that constitutes the fact. Now let's put all of this into the context of tables in a data model. If we have one table each that represents our dimensions of customer, product, store, salesperson, and date, and we have another table that represents the sale where all of these dimensions intersect, what we end up with is a dimensional model. The center table where the dimensions intersect is known as a fact table, and the contextual data around it is contained in dimension tables. So our sales fact table stores all the information about the transaction, including the price of the suit, minus any discounts, plus any taxes, plus any other fees like the fee to tailor the suit. Typically, but not always, the data you find in a fact table is mainly numeric data. It's designed to be summed, counted, or otherwise aggregated in some way. You won't find any attributes in this table about me, the suit, the salesperson, or the store. That data is all stored in the dimension tables. In the customer dimension table, you'll find all the pertinent data about me, the customer, my first and last name, my sex, maybe my age, my height and weight, my phone number and email address, and so forth. And of course, there are other customers in this table, and we exist in the table at a grain of 1 row per customer. In the product dimension table, you'll find the brand name of the suit, what category of suit it is, what color it is, how many buttons it has, maybe even really specific attributes, like whether it has a single vent on the back or a double vent, or no vent. And all the products sold by the company are kept here at a grain of 1 row per product. In the salesperson dimension table, you'll find the first and last name of our salesperson, their sex, phone number, and email, as well as perhaps that same information about their supervisor. And the grain of this table is 1 row per salesperson. In the store dimension table, you'll probably find the store number, the name and contact info of the store manager, its physical address, its mailing address, its business hours, and so forth, and all of that being stored at a grain of 1 row per store. Finally, in the date dimension table, we'll find contextual information about that date on the calendar. What year was it? What month of the year was it? What day of the month? What day of the week? What fiscal year was it? What fiscal quarter? Did it fall on a weekday or was it during the weekend? Was it a particular holiday? And so forth. And here the data is stored at a grain of 1 row per date, containing every possible date on the calendar that we can conceive reporting against. Put all of this together and the result is a dimensional model. So once we understand the business context and each of the dimensions and facts involved, we can develop dimensional models inside Power BI Desktop. This particular kind of dimensional model is known as a star schema, and hopefully it's obvious why. When you put the fact table in the center and surround it with the dimension tables that provide all the context for the fact, you end up with a diagram that looks a lot like a star. In this kind of model, you typically have and will want to have relationships between these tables that have a cardinality of 1 to many, with each dimension table being on the one side of the relationship and the fact table being on the many side. That's why I was pointing out the grain of each dimension table a moment ago. As a customer, I can come back to that store or go to another store as many times as I want and buy as many various products as I want from different salespeople on different dates. And that salesperson will probably sell many different suits to many different customers across many dates. So the fact table will probably have many, many more rows in it than the dimension tables will have, because the fact table acts as a running record of all the various sales transactions that occur for that business across all their stores, all their salespeople, all their customers, and all their products across their many years of operation. The star schema dimensional model is considered the pinnacle of data model design in the Power BI world. While it is not always possible to build a true star schema for every project, it is generally considered desirable to do so for multiple reasons. The first of these is that star schemas are easy to understand for both technical and non-technical users. When you describe star schemas using an example like I just did, where we define a business process and each of the entities involved, and then translate those into tables in our data model, everything just kind of makes sense. You don't need to be a hotshot data warehouse developer to see how these tables fit together to create a model where we can analyze retail sales. And this ease of understanding is important because Power BI is designed to be a tool that technical and non-technical users alike can employ to build reports. But the more complicated the data model is, the harder it will be for non-technical users to understand it and use it. The star schema strikes that amazing balance between being flexible enough for intensive analytics while also being simple enough to use for self-service report building. The other big reason to use star schemas is performance. We have 6 tables in this hypothetical model, and all the dimension tables have a one-to-many relationship to the fact table. Because there's only one relationship that separates each dimension table from the fact table, whenever we're filtering the data and performing calculations in DAX, there's only one relationship that each set of filters needs to traverse in our data model. If I issue a command to the data model to return all sales for customers who have brown eyes, that filter command moves very simply from our customer dimension to our sales fact and retrieves that data. In contrast, if I had a product dimension and a product category dimension beyond that, and I sought to filter all sales by product category, that means my filter command has to traverse through 2 tables. In fact, in this example, I have a product subcategory dimension as well, so I have to transit through 3 tables, and this can absolutely have a performance impact in my report. This kind of data model is often referred to as a snowflake dimension or snowflake schema, which is one of the main competitors, if you will, to the star schema. It's just a different philosophy about data modeling, and sometimes the star schema advocates like myself will playfully butt heads with the snowflake schema loyalists out there. Snowflake schema designs have their benefits, namely flexibility, but the Power BI community is generally more accepting of star schemas because of their performance and usability. The interesting thing about our AdventureWorks data warehouse is that some of the data we're dealing with exists in a snowflake schema design, so we will get the opportunity to show how you can use Power Query to merge those snowflake dimensions together in order to produce a single consolidated dimension table that will produce a star schema. I'll include some reading below from Microsoft about star schemas, and I encourage you to read it. Not all of it will make sense to you yet, unless you're already familiar with data warehousing concepts. For instance, I don't expect you to know anything about slowly changing dimensions, and we won't cover that in this course. But definitely read the top several sections that talk about star schemas and their relevance to Power BI development. The subject of star schemas absolutely comes up on the Power BI Data Analyst Certification exam, and it will probably come up in any job interviews that you have for a Power BI analyst or developer position. Power BI has multiple storage modes for working with data. We covered this topic briefly in week 1 when I was walking you through my elaborate cooking analogy. The storage mode that we've been using so far, known as import mode, is where we copy data from our data sources into our tabular model using that in-memory storage engine. And the Power BI report uses DAX to retrieve the data from the tabular model. That's why we call it import mode, because Power Query literally imports the data from the source into the in-memory database and keeps it there to be used in our Power BI report. And import mode works great for most scenarios in Power BI development. That in-memory storage engine is the secret sauce that makes Power BI reports so snappy when you interact with them. Those DAX queries that we looked at last week are retrieving the data that has been loaded into your computer's memory, achieving lightning-fast results. And that storage engine can handle a lot of data too. But what happens when the data gets too big to fit into the storage engine? Or what if you're dealing with a situation where you might want to access data closer to real time rather than having to refresh the data set every time you want to get the latest information? Well, this is where other storage modes come into play. The main alternative to import mode is known as DirectQuery mode, and it works by bypassing the storage engine entirely and simply retrieving the data directly from the data source into the report. This has multiple effects on your data model. First, you no longer have a size limit to worry about because the model doesn't import any data. With DirectQuery, the model only consists of the metadata that defines the structure of the model, but it doesn't store anything from the data source. Second, you no longer need to worry about refreshing the data model, either manually or via scheduling, because DirectQuery will automatically get the most recent data for you every time it requeries the data source. As we've seen in our lessons where we used the performance analyzer, clicking a slicer or cross-filtering a visual is all it takes for Power BI to issue a new DAX query to the dataset. So, if your report is plugged into a database using DirectQuery mode, that means if a business user goes in and changes the data, like to record a new sale, the next time you change a slicer selection in your report, Power BI should automatically pick up that new data. Now, DirectQuery has its downsides. First of all, only certain data sources even support DirectQuery in the first place. Those data sources are typically limited to relational databases and data warehouses like Oracle, Microsoft SQL Server, and Snowflake. But other data sources that we've been using in this course, namely CSV files and web APIs, don't support DirectQuery. And the reason has to do with the underlying technology behind each data source. DirectQuery works by taking the recipes that you build in Power Query, and it translates those commands into queries that the data source will recognize. For a SQL Server database like the one we're working with in our lessons this week, that means DirectQuery mode will translate our Power Query recipes into SQL code, and it will issue those SQL commands to the database in real time, and then it will return the results. So, in essence, DirectQuery acts as a translation engine between the language of Power Query and the language of the data source. We'll get to see this in action in our upcoming lessons, and it's really cool, but it also means that not all data sources can use DirectQuery mode. The next downside to note is performance. Because DirectQuery doesn't store any data in the model, it has to go to the data source to get the data every time it issues a new DAX query. Like I said a moment ago, it's bypassing the storage engine and dynamically generating commands to issue to your data source. And depending on your data source and how well it's optimized, that could lead to performance issues. You'll see this when we begin using DirectQuery because you'll see how it takes longer for our report visuals to update when we cross-filter or cross-highlight in the report page. And when you think about it, it should make sense as to why. When we're running a Power BI data model in import mode, our dataset is brought into our system memory so that memory provides fast access to the data, and the data doesn't have far to travel because the report and dataset are both sitting on the same hardware. On the other hand, when running DirectQuery mode, if you're querying a database that sits on a totally separate server somewhere, like a cloud data center, well, that's going to slow things down a bit because Power BI needs to build that query and then send it to the data source, and then the data source needs to do its own computation to translate that query, get the results, and then send it all the way back to Power BI. The end effect of this for Power BI users is that while report visuals running in import mode will update nearly instantaneously when you interact with them, those same report visuals when running in DirectQuery mode may take more time to update, sometimes several seconds. Now, one way DirectQuery gets around that performance slowdown is that it will temporarily cache your query results for each visual. So if you were to select East Asia on a slicer, and Power BI uses DirectQuery to get a list of all the countries in East Asia and puts those results into a table visual, those query results will be kept in a cache behind the scenes. So if you click off East Asia to go to North America, and then you go back to East Asia a few seconds later, DirectQuery will use that cached set of query results instead of issuing a brand new query to the data source. That helps your report performance while also avoiding a situation where you just keep hammering your database server with a bunch of redundant queries. Now, the final downside to DirectQuery is that it imposes some constraints on what kinds of data transformations that you can do in Power Query. Not all data transformations that you find in the Power Query editor are supported by DirectQuery mode. If you try to build a DirectQuery report, but you choose a data transformation that is not supported by DirectQuery, the Power Query Editor will tell you that it is not supported, and it will ask you if you want to switch from DirectQuery to import mode instead. If you don't want to switch to import mode, you have to remove that data transformation step and try to find another way to accomplish what you need to do. Now, the discussion of DirectQuery can get really complicated because it is possible to build data models that have some tables running in import mode and other tables running in DirectQuery mode. These are known as composite models, and as a matter of fact, you can even configure some tables in your data model to run in both import mode and DirectQuery mode simultaneously. These are known as dual storage tables or hybrid tables, and they work by partitioning the rows in the table into one set of rows that are queried by DirectQuery, and then another set of rows that are imported into the storage engine. These are complicated data modeling scenarios that we don't have time to cover in this course, but I want you to be aware of their existence because they can be useful in scenarios where you're dealing with enormous volumes of data, or perhaps a mixture of high volatility data that changes all the time alongside low volatility data that doesn't change very often. Over the next few videos, we'll use DirectQuery mode against our AdventureWorks data warehouse so you can get a sense of how it works, and we'll explore some of these upsides and downsides. Connecting Power BI Desktop to the AdventureWorks data warehouse is incredibly simple. You just need the server name that you either memorized or wrote down somewhere after we installed SQL Server Express a few lessons ago. Then, once you've opened up a new instance of Power BI Desktop, go ahead and click the button to import data from SQL Server. In the box that pops up, the server name will have our localhost /SQL Express instance name in it. We don't need to provide it with a database name, so don't worry about that, but I do want you to select DirectQuery from the data connectivity mode down below. Then let's click OK. Once we're connected, you'll see the name of the SQL server and then the name of any databases that are available on the server. And we see our AdventureWorksDW 2022 data warehouse here, so we can expand to see all of the views and tables underneath. Before we go any further, take note of the names of the tables that we see here, and remember our discussion of dimensional modeling and star schemas. We have a whole bunch of tables that have the prefix of dim in their names, which stands for dimension, and we have several more down below that start with a fact prefix, which are obviously our fact tables. We can select any one of these tables to get a preview of the data in the database. For example, if we select Fact Finance, we see that it's only got a few columns in it if we scroll to the right. And if we select this button that says Select Related Tables, Power BI will go ahead and select any other tables in the database that relate to our Finance Fact table. Let's go ahead and hit Transform Data now to bring all of these tables into Power Query. Once the tables are loaded in Power Query, you can probably see that a star schema might be about to take shape because we have a single fact table and 5 dimension tables. And if we look at our fact table and these key columns that are in it, we can tell that they correspond to each of the 5 dimension tables. In the world of databases and data warehouses, these 5 columns on the fact table are known as foreign keys. They form the connection from the fact table to each dimension table. In much the same way, over the past 2 weeks that we've used country codes or state abbreviations in Power Query to merge tables together and create relationships, these 5 foreign keys here create the relationship from the fact table to the 5 dimension tables that surround it. The other column that I'll bring your attention to here is the finance key, which starts at 1 and goes up from there. This is known as the primary key. It is the column that uniquely identifies every row in our fact finance table. And if we change our view to one of the dimensions, such as dim organization, we can see that it also has a primary key named organization key. So the foreign keys that exist on the fact finance table are derived from the primary keys of the table they relate to. The primary key that identifies, for example, a particular row in our dim organization table can be used in the fact finance table to connect its rows back to that organization dimension. Creating primary keys and foreign keys is a vital aspect of database design because it allows us to create what is called referential integrity, which is a fancy way of saying that we know we have all of the rows of data that we need. For example, if we go back to Fact Finance and look at the account key column, there should not be any values in this column that do not exist in the dim account table. Every row that exists here should exist in the related table as a primary key. If it does not exist on the related table, we have what is known as an orphaned record or an orphaned row. In other words, if you think of the dimension table as the parent and the fact table as the child, an orphaned record on the fact table would be like a child record that does not have a parent record. The presence of orphaned records in a dataset can cause issues in our calculations, so we want to have referential integrity, and adding primary keys and foreign keys to databases is a good way to ensure that we do. But that discussion probably goes a little too far down the rabbit hole of how to build databases and data warehouses, and that's not the subject of this course. If you want to learn more about referential integrity, you should take my edX course on how to work with SQL databases, because I cover that topic in greater depth there. Now, our data warehouse is doing us a big favor here, as you can see, because our data is already in a dimensional model, so we really don't have to do a lot of data transformation here. So let's go ahead and hit Close and Apply and load everything into Power BI Desktop. We won't make any changes to these queries yet. Once we're in Power BI Desktop and the model is created, let's go to the model view to take a look at it. If it doesn't look like a star, you can click and drag the tables into a shape that resemble a star if you'd like. And there we go. That kind of looks like a star with the fact table in the middle and surrounded by each of the dimension tables. You'll also notice how each table has a blue bar at the top of it, which symbolizes the fact that these tables are all queried via DirectQuery. If they were in import mode, there wouldn't be a blue bar. And finally, note all the table relationships that were created using the foreign keys from the fact table to the primary keys on each dimension table. And all of their cardinalities are one-to-many. This right here is a textbook star schema in all of its glory. So let's test this out by adding some quick visuals. I'm going to add a table, and then I'm going to put scenario name, and I will put sum of the amount column. Yes, this is an implicit measure. Please forgive me for using an implicit measure. Then let's add a bar chart on which I will put English month name from dim date, and then again I will put the amount from Fact Finance. Then I'm going to go to English month name and I'm going to sort it by the month number of year. Then I'll sort my chart like so, sorting by English month name in ascending order. So what I did there, just make sure that my months are sorted not alphabetically, but are actually sorted by the month number in the year. Now let's change the interactions from cross-highlighting to cross-filter by going to Format, selecting our table, Edit Interactions, and I'm going to change this to cross-filter. Now for the next part of this, I'm going to close the Filters panel. I'm going to go to the Optimize tab, and I'm going to turn on Performance Analyzer. And then I'm going to start recording. So the first thing I'm going to do is I am going to select a budget row, the budget row, from our little table over here. We see how everything's changed. And I'm just going to stop recording. And now I'm going to open up the Performance Analyzer, copy our query. And now I'm going to open up a tool like Sublime Text. So in Sublime Text, I have pasted the query that I copied out of our Performance Analyzer. Notice that the first part of the query has a comment that says DAX query on line 1, and indeed it is a DAX query. This is what the report can use to query data that has been cached in our report. But the lower part of the query, which says DirectQuery on line 24, is what we're interested in. This language that you see here, if you're not familiar with it, is SQL or SQL, standing for Structured Query Language, the language of most relational database systems in use today. There are many dialects of SQL out there, and this particular dialect is known as T-SQL or Transact SQL, and it is the variant of SQL that is used by Microsoft SQL Server databases, which is what our AdventureWorks data warehouse is. We can copy these lines of SQL from our text file, and then we can paste these into SQL Server Management Studio. In SSMS, just right-click on AdventureWorksDW 2022, select New Query, and then paste the query into the new query editor, and let's run it. So now, just like we did with DAX Studio back in week 2, we're seeing what Power BI was retrieving from our data warehouse when we clicked on the table visual. Of particular interest is the line in the query down below where it says where T5 scenario name is equal to budget. What you're seeing here is DirectQuery dynamically generating a SQL query to our data warehouse based on the data that we selected in our report when we clicked on the table visual. Now, this particular SQL query is, in my personal opinion, way more complicated than it needs to be because you have all of these subqueries inside of here. But sometimes auto-generated SQL can be that way. Regardless, the query performance is quite fast, and it still allows us to demonstrate what it looks like when we've chosen to use DirectQuery for our Power BI reports instead of import mode. So let's head back to Power BI Desktop, where there's one more thing that I'll point out. Notice how there is no data view in our report. We only see the report canvas view, which we're currently in, and the model view. That's because we're in DirectQuery mode. Power BI can't show us the data view when we're in this mode because there's no storage. Thus, we have no data to look at in our report until we actually start building visuals in the report canvas like we did. So, in our next lesson, we'll examine a little more closely how all of this looks and works inside of Power Query. So, we're back in Power Query looking at our finance data model from the AdventureWorks data warehouse. And thanks to our performance analyzer in the last lesson, we've gotten a chance to see how a Power BI report communicates with our data warehouse when the data model is running in DirectQuery mode. Now, let's explore this a bit more on the Power Query side of things, and let's tackle one of my favorite topics in the world of Power BI, which is query folding. We have our 6 queries lined up here on the left side of Power Query as usual. Let's select our dim date table and open the advanced editor to see what this looks like in our Power Query M code. We see 3 steps happening. The source step connects to our server, then there's a second step which connects to the specific database on the server, and then there's a third step that connects to the specific table we want. Now let's go to our recipe for this query and right-click on the last step in our recipe, Navigation. If we look towards the bottom of the menu, we'll see an option here that says View Native Query. When we click it, we get a small pop-up that contains a SQL query. If you're not familiar with SQL, all this query is doing is selecting a bunch of columns from the dim date table in our data warehouse. If we copy this query and then paste it into SSMS and execute it, we can see the same result there that we saw in our Power Query editor. Now let's head back to Power Query and let's remove some columns that we don't need. I'll open up the Choose Columns window and select the ones that I want. And perfect. This adds another step to our recipe, and if we go back to the View Native Query option on the last step, we can see that our SQL query has gotten shorter, because now Power Query is only asking our data warehouse for the columns I selected. Now let's suppose that I want to add a couple of columns that give abbreviations for the day of week and the name of the month. Currently, those 2 columns display their full name, as you can see here and here. But what if I just want to get the first 3 letters from each of them? Well, I can either use my Transform tab or my Add Column tab. It doesn't matter which, because the function I'll use is the same. I'm going to go to Transform, then to my text functions, then Extract, and First Characters. In the pop-up box, I'll input the number 3 and click OK, so I'm only telling Power Query to get the first 3 characters from the column. And then I'll do the exact same thing for the other column. Then let's go back to the View Native Query thing again and look at our latest results. Our SQL query has gotten a bit longer because now it's using something that we call a subquery, which is this section inside of parentheses right here. But the main thing I'll draw your attention to is the use of the left function on these lines. This is Power Query translating the two steps that we just did into SQL commands for our data warehouse. Now let's get rid of some rows that we don't need. Our dim date table stretches all the way back to the year 2005, as you can probably tell by looking at the date key column here. But if we look at our fact finance table using our column profiling features, we'll notice that there are no dates before the year 2010. So in our dim date table, we can actually filter out any rows prior to 2010 because there are no fact records to correspond to those years anyway. So let's add a numeric filter on here that only returns dates where the calendar year is greater than or equal to 2010. Scroll to the right, find the calendar year, then number filters, greater than or equal to, and input the year 2010. Then click OK. This adds yet another step to our recipe, and if we go to View Native Query yet again, we see that the query has gotten even longer, and now, towards the bottom, there's a where clause that says where calendar year is greater than or equal to 2010. Now, this is where I want to stop and talk about query folding. We've done multiple transformations to our data in Power Query by this point, all of them spread across these 4 different steps of our recipe, starting with removed other columns and ending at filtered rows. But, as you can see when we go back to View Native Query, Power Query has consolidated all of those transformations into this one SQL query here. We have selecting the columns that we want, transforming the columns, and then filtering the rows. So, although Power Query represents all of these transformations in 4 different steps, the whole recipe is actually being folded up into a single step, and this is what is being sent down to the data warehouse to retrieve our data. This is query folding. To put it simply, using Microsoft's official definition, query folding is the ability for Power Query to generate a single query statement to retrieve and transform source data. And the reason it's doing this is A, because it can, and B, because this is far more efficient than sending a bunch of separate SQL queries to the database. Power Query's brain, for lack of a better word, has looked at our recipe and said to itself, yeah, I can fold that. So it dynamically generates a SQL query that performs all of these transformations in a single statement. You probably recall me saying that the star schema is the pinnacle of data modeling for Power BI developers. Well, query folding is the pinnacle of efficiency in Power Query. But why? Put simply, the reason is workload. Maybe you've noticed by now in the time that we've been working with Power Query, but sometimes it can be a little bit slow. And that's because Power Query has to use a lot of your machine's resources to perform its data transformations. And when data models start to get bigger and more complex, then Power Query can take longer and longer to perform these transformations if it doesn't have enough compute or memory to complete them quickly. That's where query folding can be an enormous help to Power BI developers. By folding all of those transformations into a single query statement and sending that down to the data warehouse, Power Query allows us to take advantage of the data warehouse's resources. In this course, we're using a data warehouse that is deployed locally, but the more common way you'll see a database or a data warehouse deployed is on a standalone server, and usually those servers have some really beefy specifications. My computer here has 32 gigabytes of memory today, but a proper data warehouse server might have 4 times that much memory, plus a much faster processor, because it needs to handle tons and tons of data for hours a day, every day. With query folding, then, we can get a huge boost in performance because now Power Query is not relying solely on its own resources to transform the data. By leveraging query folding, we can employ that server's enormous resources to make data retrieval even faster and even more efficient. However, if you use a data transformation that is not supported by query folding, then that advantage goes away. This is known as breaking the fold, and it's why you'll hear many Power BI professionals tell you, don't break the fold. If you break the fold, you lose the performance advantages that query folding gives you. Let's go to our fact finance table. We can tell that we have query folding happening here because the final step in our query has the View Native Query option enabled. That tells us that there is a native SQL query being generated, which means query folding is happening. Now, notice how the date column here has both dates and times in it, despite the fact that all the times are set to 12 o'clock midnight. Well, we don't need those times, do we? If they're all set to 12 o'clock midnight, we probably don't need them to be there. So we can convert this column into a simple date column and get rid of that extra information, right? Well, let's go to our Transform tab and look at the options under the Date and Time column settings, and specifically under this Date menu, where we see an option called Date Only. That sounds promising, right? Well, let's click it and see what happens. Okay, cool. It removed that time data that we didn't need, but look at what else has happened. We now have a yellow banner at the top of the page telling us that this transformation isn't supported by DirectQuery mode, and it wants us to switch to import mode. Furthermore, if we go to our recipe and right-click on the final step we just created, we can now see that the View Native Query option is grayed out. To quote the Power BI guru Patrick LeBlanc, what the French toast? That grayed out option there, that's Power Query telling us that we broke the fold, because we picked a data transformation that query folding does not support. That means Power Query can no longer generate a SQL query that can process all of the transformations in our recipe. And not only has that broken the fold, but it also means DirectQuery mode is no longer a valid option for us on this table. In order to use the transformation we selected, Power Query needs us to switch to import mode. Thankfully, in this particular situation, there is a way out. I'm going to delete that step from our recipe. Then I'm going to go to the date column, open up the data type menu, and change it from date time to just date. And this ends up accomplishing the same thing, but notice that we're no longer being told that this is not valid for DirectQuery. And notice how the View Native Query option is still enabled. If we look at it, we can see that it generated a SQL query that uses this convert function to transform the original column into a date-only column. Problem solved. Now, what would have happened if we had switched that query to import mode back when it was broken? Would we have lost query folding entirely? No, not at all. Query folding is supported in both DirectQuery mode and in import mode. That means a table running in import mode that uses query folding will refresh its data from the data source super fast, while the same table running in import mode without query folding will be much slower to refresh its data. But query folding is not an all or nothing proposition. You can have query folding occurring for part of your query, but then if you use a transformation later in your query that prevents folding, that step in your recipe and every step after it will not have the benefit of query folding. That means when you're working in import mode, it is possible to have a query that starts with query folding, then breaks the fold, and then the rest of the transformations will be processed inside Power Query. It's good to avoid breaking the fold if you can, but sometimes it's unavoidable. For example, query folding cannot occur when you are trying to merge two tables from two different data sources. Query folding works because it's able to use the resources of the server that host your data source. But when we're combining tables from two different data sources, Power Query doesn't have any way to apply query folding because those data sources can't necessarily see or communicate with each other. They're probably on different servers, maybe even different data centers entirely. The only thing that they have in common is the connection to Power Query. So in that situation, Power Query needs to bring the data from both sources into its mashup engine and perform the transformations there, which means no query folding can occur. You could use query folding to perform data transformations against the first source and the second source, separate from each other, until you are ready to merge them together. That would allow you to take advantage of query folding on each of the separate data sources up until the point that you need to bring the data together. But once you merge them together, there is no more folding that's possible. This was just a quick introduction to query folding. I'll include a link below that takes you to Microsoft's official documentation on the subject so you can get a better sense of the types of transformations that can achieve query folding and those that prevent it. Honestly, sometimes it takes trial and error to figure these things out, so I always tell Power BI developers when they're connecting to a data source that supports query folding to always pay attention to that View Native Query option to let them know when they've achieved query folding or when they've broken it. Always remember, don't break the fold. Not unless you absolutely have to. With large databases and big enough data sets, you'll be glad to achieve query folding because it can drastically improve the time it takes to retrieve data from your data source. One way to improve the performance of direct query models in Power BI is through the use of parameters. These parameters can be enormously helpful in situations where your users only need to look at, for example, one category of data at a time. By implementing parameters with DirectQuery, you can drastically speed up the time it takes for your report to retrieve data from the data source, which can be a big deal if your data source is big enough to warrant these kinds of strategies. To begin, we'll go to Power Query and we'll add a parameter here. On the Home tab, there's a section called Parameters and a button that says Manage Parameters. If you open this up, you can see an option to manage parameters or go ahead and create a new one. Let's click on Manage Parameters, and this will open up a pop-up where we can create a new parameter by clicking the New button here. I'm going to call our new parameter P Department Group, and we can give it a description down below if we want. We can also set whether or not it is required or optional. I'm going to change the type to decimal number, and I'm going to give it a placeholder value of 5. Then click OK. And in our left-hand panel, we can see that we now have a new object called P Department Group with a current value of 5. Now let's go back to our Fact Finance table, and let's find our Department Group key, open the filter controls, go to Number Filters, and Equals. When the pop-up opens, there is a small drop-down menu between the operator menu here and the value menu here, which is where we can select whether or not this parameter should be a static decimal number or it should be bound to a parameter. So we can select parameter, and then we get the P Department Group parameter in our drop-down menu. When I click OK, we'll add another step to our recipe, and if we look at the Power Query M formula, it simply says where each department group key is equal to the department group parameter. And if we go to View Native Query, we can see that there's a where clause that specifies where the department group key on our Fact Finance table is equal to 5. Now click OK, and let's close and apply to exit Power Query and return to Power BI Desktop. Let's take a moment to see what effects that had on our data model. We'll start by adding a table somewhere in the report canvas, and then we'll go to Dim Department Group. We'll add the department group name, and then if we go to Fact Finance and add, say, the amount column, where again I'm using an implicit measure, we can see that we're only getting data for the Quality Assurance Department. If we also add the department group key to this table and put that in place, move things around a little bit more, we can see that department group key is equal to 5. So our parameter is currently in action on this report. We're only looking at department group key number 5, which is our Quality Assurance Department. Now, we can change the parameter value inside of Power BI Desktop. If we open up the menu under Transform Data, there's an option to edit parameters, and inside of here we can change the department group parameter from 5 to, say, 4. Power BI will prompt us to apply changes, which I will do, and it will re-query our data model, and now we're looking at the manufacturing department. Now, ultimately, our goal in this exercise is to create a slicer that allows us to change that parameter dynamically. So, in a real-world scenario, our users could select a department group from the slicer, and that would re-query the data warehouse to pick up a new department. So let's see how to do that. The first step is we need to go to our data model, find the dim department group table, and we need to change a few configuration settings. First of all, I'm going to set the row label and key column properties, which you can see here. The key column property is simply whatever column uniquely identifies each row in our table. Thinking back to a few lessons ago when we talked about foreign keys and primary keys, the primary key is the column that uniquely identifies every row in our table, which in the case of dim department group is our department group key column. So we'll select that from the dropdown. Now the row label property is whatever column we use to label each row in the table. In this case, that's going to be the department group name. Once we do that, you can see that two little icons have been added to the dim department group table next to department group key and department group name. These just help us identify which columns are being used as the key column and the row label. The next thing we're going to do is we're going to select the department group key from the table, and then we're going to scroll down into the advanced settings on our properties panel. Within here, you'll see that there is an option to bind this column to a parameter. If I click this, we'll see our department group parameter in the menu, so now we can select it. It will tell us that there is a potential security risk to using dynamic Power Query M parameters. In this case, there's not really a big risk, so I'm going to hit continue, and that is going to bind our department group key column to the parameter that we created in Power Query. Now let's go back to our report canvas and let's add a slicer on here on the left-hand side that allows us to pick a department group. I'll add a slicer object, and then on that slicer, I will add department group name. Now let's watch what happens if we switch to research and development. It took a few moments, but Power BI used the slicer to query our data warehouse and return the research and development information. Let's see what this looks like using our performance analyzer. We'll go to the Optimize tab on our ribbon, open the Performance Analyzer panel, and start recording. Now let's select a different department. I'll select Sales and Marketing. Give it a few moments for the query to run, and there we go. Now let's stop recording. Then let's select one of our tables. We'll say sum of amount by English month name, which is our bar chart. Then we can copy that query, open up a text editor like Sublime Text, paste the results in here. We can see where Power Query automatically generated a where clause spanning from lines 126 to 129 that took the value department group key equals 7, which is our sales and marketing department, and passed that down to the data warehouse to retrieve the results. So what we've demonstrated here is that when we select each option from our slicer, that department group key is getting bound to the parameter that we created, and that in turn is telling Power Query how to construct the SQL command that it sends to our data warehouse. Parameters can also be used in import mode, but they can't be dynamic like this when done in import mode. In that mode, I often use parameters as a way to store repeatable information like server names and file names and API keys, or to store key variables that don't change often, such as a start date and end date. Overall, parameters are most useful in direct query situations like this one, where we want to use them dynamically, like we did here, to achieve faster performance times against larger data sources. For our main exercise in week 3, you'll step into the shoes of a data analyst who works in the IT department at AdventureWorks. Brian Welker, the Vice President of Sales, has asked your manager to lend him a data analyst to build a new Power BI report, and your manager thinks that you are the perfect candidate for this task. AdventureWorks sells their sports equipment all over the world, and they employ a bunch of sales representatives, or sales reps for short, to travel, meet with customers, and make sales. Each sales rep reports to a sales manager, and that sales manager is responsible for a specific territory, and all of the sales reps who cover that territory. For example, there's one sales manager responsible for all of Europe, and another responsible for North America, and so forth. Each sales manager reports directly to Brian, who oversees the entire department. At the start of the work week, Brian calls you into his office to explain his vision, which is to have an interactive sales dashboard that allows him to see some basic information about all of his employees and their sales performance over time. This kind of meeting is typically known as a business requirements meeting. Brian comes to the meeting prepared with a list of some key questions that he wants answered, as well as a list of features that he would like to see in the sales dashboard. I won't read through all of these, but let's summarize some of the key points. First, we can see that multiple people will be looking at this dashboard, and they'll have various roles. Brian, as the VP of Sales, needs to be able to see everyone's data, but sales managers should only be able to see their own data plus the data of any sales reps that they manage, while the sales reps should only be able to see just their own data. In Power BI, this kind of functionality is accomplished through row-level security, a data modeling technique that uses DAX to filter our data based on values in the dataset. This is a pretty common request in organizations where we want to make sure people looking at reports can only see the information that they need to see. Second, Brian asks us for some basic sales measures, like lifetime sales for each person, as well as sales totals for the current year and previous year, and finally, year-over-year sales growth. But he also asks year-to-date sales totals for the current year and wants us to compare those totals to the same period from the previous year. This isn't something that we've covered yet in this course, and it requires us to dive into the world of time intelligence functions in DAX, which will allow us to calculate sales amounts over various time periods to answer Brian's questions. Third, Brian wants to have photos of each salesperson visible and a clickable email link for each of them. Both of these can be accomplished with a little bit of magic in Power Query. Fourth, Brian wants to be able to drill down and see details about each salesperson. He's asking for a lot of information in these questions, so we can conclude that a tooltip page probably won't be big enough to hold all that data. Instead, we'll probably need to build a drill-through page. Fifth and finally, Brian tells us that the sales data doesn't change very frequently. Since this is a low volatility dataset, we probably don't need to use DirectQuery for this data model. Instead, we can rely upon import mode. Brian gives us a head start on our report design by giving us a rough, hand-drawn sketch of how he wants the report to look. On the first sketch, we can see he wants a company logo, a filters panel on the left-hand side, and a table listing the salespeople with their photos, email links, and some of their sales figures. On the second sketch, Brian went into even more detail. We see several card-like visuals at the very top next to the salesperson's photo, and then we see a bunch of charts or widgets laid out below. The first one on the top row looks like a bullet chart because we have these black lines that are often used to represent targets or comparison values on bullet charts. The next one on the top row looks like a basic table. Then on the bottom row, we have some boxes that just say top-selling products and top-selling resellers. So it seems Brian doesn't know what he wants here and is giving us some creative freedom to figure it out for ourselves. And lastly, he sketched out a line chart or area chart in the bottom right corner that has months on the x-axis, and we can see that he wants to view current year sales totals overlaid on top of previous year sales totals. As a well-trained Power BI developer who is familiar with the AdventureWorks data warehouse, you know that all of this can be accomplished. You tell him that you'll have a prototype dashboard for him by the end of the work week. Now that we have a good idea of what requirements Brian has for this project, we can begin working on it. In the next video, we'll begin building our data model in Power Query. In this video, let's open a new report and begin building the data model for our sales dashboard project. Completing the data model will take a few videos, so let's start with just connecting to the AdventureWorks data warehouse and importing the tables that we need. First, we'll choose to import data from SQL Server using the button on the report canvas. When the window opens, put in the name of your SQL Server instance, and you can choose to include the database name or not. Make sure that you're in import mode, then click OK. For this project, we need to get the fact reseller sales fact table. So select this from the list of tables, then select related tables. I'm going to go ahead and tell you that we do not need dim currency and we don't need dim promotion. The other 5 tables we can keep. Now let's hit Transform Data and bring this into Power Query. Let's begin by explaining each of these tables. DIM Sales Territory just contains some basic information about the various sales territories that our sales representatives are assigned to. DIM Reseller, on the other hand, has a lot more complex information. This has the names, business types, and contact information for the various resellers that AdventureWorks does business with. DIM Product is where things get a lot more interesting, because now we have a dimension table that gives us one row per product that AdventureWorks sells. Notice how we also have product photos and product descriptions in various languages. The other thing that we have that we'll be leveraging later is this link to the DIM Product subcategory table. Now, we did not import this into Power Query initially, but that's okay, because I'll show you how we can add this without needing to go back to our getData function. Meanwhile, DIM Employee is a table with one row per AdventureWorks employee, consisting of product engineers, marketing people, technicians, and if you scroll down far enough, you'll start to find our sales team, sales representatives, sales managers, and the Vice President of Sales himself. DIM Date, meanwhile, is a table with one row per date. This table contains information about what day of the week it was on a particular date, what month, what week of the year, and so on and so forth. Finally, our Fact table. Fact Reseller Sales has links to all of the dimensions that we need to use, including product key, order date, due date, and ship date, reseller key, employee key, and sales territory key. If we scroll over further, we'll also find some currency fields, such as unit price and sales amount. Sales amount is the one that we'll focus on. And if we continue scrolling, we'll even find some date columns, such as order date, due date, and ship date. Let's begin with DIM Product. First, we'll start by removing any columns that we don't need. So I'll go to our Choose Columns feature, unselect everything, and start selecting the ones that I want. I will definitely need product key because that's the primary key that links me to the foreign key on Fact Reseller Sales. We'll also want the product name, maybe the class, style, and model name, the English description perhaps, and we need the DIM Product subcategory table. We click OK. Now we can expand to get the attributes from DIM Product subcategory. If we click and expand, we can see that we have fields to choose from, such as the product subcategory name in English, Spanish, and French, as well as a link to DIM Product category, which is the other table. Now remember, in my earlier video about star schemas versus snowflake schemas, I promised you that we would get to look at a snowflake schema, and that's what you're seeing. Instead of having all of the product information in a single dimension, this data model has actually spread it out across 3 dimensions, including category and subcategory. Let's just get the English subcategory name and the DIM Product category table. Then let's expand DIM Product category and grab the English product category name. Lastly, let's rename our columns. I will call English product name product, model name is model, English description is just description, English product subcategory name will become product subcategory, and the English product category name will become product category. Perfect. Now let's look at DIM Employee. First, we'll start by getting just the columns that we need. So we'll go to Choose Columns, unselect everything, then we'll grab Employee Key because that is the primary key, first, last, and middle name, as well as job title and hire date. Scroll further down, we'll grab email and phone. Scroll further down, we'll also grab department name, and we'll grab the employee photo and the DIM employee using parent employee key and DIM sales territory. Next, let's expand this DIM employee using the parent employee key, which allows us to pull in our supervisor information. We'll grab first and last name and job title. Oops, almost forgot. Make sure to add the email address column too, because we'll need our supervisor email addresses later. Now click OK. And then let's scroll to the right and expand DIM sales territory, where we will grab sales territory region, country, and group. Then click OK. Next, we need to filter our employee table down to just the employees who work in the sales department. So we'll go to our department name column, open it up, unselect everything, find and select sales, and click OK. Next, let's do a little bit of transformation on this. I want to create two columns, one that provides us with sortable names, starting with last name and first name, and then another one that provides first name followed by last name. So we'll go to Add Column, we'll select both first name and last name, and then we will say Merge Columns on our Add Column tab. Our separator will be a simple space, and we're going to call this Name. Click OK, and the name column will be added to the end of our table, right there. Next, let's go back, and this time let's select last name followed by first name, and again hit Merge Columns. Now we'll do a custom separator, where I will put in a comma and then a space, and this will be called Sort Name. Click OK, then scroll to the right, and we can sort this in ascending order. This gives us an alphabetically sortable list of our salespeople. Let's take a moment here and right-click and view native query, and we can see that we're getting query folding on this. So this is great. Make sure to go through all of your queries actually and use the View Native Query feature to see what the native queries that we're getting look like. Now let's start renaming some columns. Scroll through, see if anything looks out of place. I'm going to rename department name as department. We're also going to take our supervisor first name and last name and merge those into a new column. So let's go ahead and do that. Separator will be a space, and we will call this supervisor name. Now we can actually remove these two columns, and I'm actually going to go back and remove the first, last, and middle name from earlier because we don't need those either. We have title, hire date, email address, phone, department, employee photos, which we'll deal with in a later video. We have our job titles, but this is for our supervisor, so I'm going to rename this from title.1 to supervisor title. Also remember to rename the email address column that you brought in with the rest of the supervisor data and rename it as supervisor email. We have our sales territory region, which we'll just call sales region. Sales territory country, which we'll call sales country, and sales territory group, which we'll call sales group. Okay, now let's go to DEM reseller. Once again, we'll start by removing the columns that we don't need. So go to Choose Columns. Click to unselect everybody. Make sure you grab the reseller key because that's our primary key. Never forget that. Then let's grab the reseller name, perhaps their business type and address. Then let's also grab DEM geography and click OK. Now let's expand DEM geography by clicking on it. And let's bring in city, state, province, code, and name, country, region, code, country, region, name. Actually, don't select the country code because we don't need it. Just get the region name and I guess the postal code. That should be everything we need, so click OK. Now let's take a look at DEM date because this one is going to be a little bit more complicated. Once again, we'll start by removing the columns we don't need. So go to Choose Columns, click to deselect all, make sure you get your date key, then get the full date alternate key as well as the day number of week, English day name of week, day number of month, day number of year, week number of year, English month name, get the month number of year, and then you can even grab the calendar year, calendar quarter, and, well, not calendar semester. We don't need that. And for this exercise, you don't need any of the fiscal columns, and you don't need any of these that connect to other fact tables. So click OK. Now let's get the first three characters of our English day name of week and English month name columns. I'll select the first one, go to Transform, Extract, First Characters, and then put in the number 3. Then repeat the same process with the month name, Extract, First Characters, number 3, click OK. Now here's where it's going to get interesting. We've got a lot of years in this DEM date table that we do not need. It starts at 2005, as you can see, but if we go to Fact Reseller Sales, we can see that the earliest information in this table comes from 2010. So we've got 5 years at least worth of data that we don't need to add to our DEM date table. So what can we do to try and filter down DEM date based on the dates that are in our Fact Reseller Sales table? To get a list of only the years that are in our Fact table, I'm going to scroll right until I get to our DEM date order date key column right here. I will expand this, unselect everything, and then grab the calendar year for our order date. I'm also going to tell it to use the original column name as the prefix. Once this is done, we have our column right here. I'm going to right click and say Add as New Query. Once it's in here as a list, I'm going to remove duplicates, and then I'm going to rename this as Years. With that done, I can now go back to dim date, and we're going to do a little bit of custom filtering here. Scroll right and find calendar year. Click on it, and then let's go to number filters, and we'll say greater than or equal to. We're going to start by putting in is greater than or equal to 2010 and is less than or equal to 2014. Then click OK. Now this gives us a Power Query M formula that you can see here, which we can use. However, I want to make this more dynamic. Right now we're using static values that we typed in, but what if we could use the values from our years query right here, which comes from our data warehouse, and put those values into our formula? It's pretty easy to do, and I'm going to show you how. We're going to highlight 2010, and we'll replace it with list.min, open parenthesis, and we'll type in years. Then we'll highlight 2014 and replace that with list.max, open parenthesis, years. Commit that change to the formula, and we get the exact same result. Calendar years now begin at 2010 and end at 2013, which is all of the data that we have in our fact reseller sales table. So you can see that by creating a list of the years that were available in the fact table and then referencing that list in this Power Query M formula here, we were able to create a dynamic filter on one table using the data from another table. The list min and list max functions that are being used here simply get the minimum and maximum values from a list that you provide to it. Now let's try to wrap up by going back to fact reseller sales and only getting the columns that we need for that. Go to choose columns. Let's get our product key and the foreign keys that we need, including order date, due date, ship date, reseller and employee keys, and finally the sales territory key. We're not going to grab promotion and currency because we don't need them. We didn't bring those tables into our model. We'll scroll down and grab the total sales amount, which is right here. And that's pretty much all we need. We can click OK, and now we have all the data that we need for our fact table. The last thing we'll do is we'll add a measure table. Let's click the Enter Data button, create a placeholder name for the column, go to the table name and put in _measures, then click OK, and now we have our measures table. One more thing, make sure to right-click on the years query and unselect the Enable Load option. We don't need to load this list into our data model. Then let's go to Home, close and apply, and watch Power BI do its thing. Once the data model is loaded, let's go to the Model View tab, where you can see that my data model did not have its relationships created automatically. So I'm going to manually create my star schema by arranging everything and manually creating relationships, which ought to be a lot of fun for everyone to watch. Sales territory key to sales territory key, reseller key to reseller key, product key to product key, then we'll do date key to order date key, and employee key to employee key. There you have it. There's our star schema. We're not quite done with Power Query yet, though. You probably noticed we have 3 date columns in our fact table: due date, order date, and ship date. However, we only have one date dimension table in our model, which is dim date, which I currently have connected to the order date key. In our next lesson, we're going to discuss the concept of role-playing dimensions and how to implement those in your data model. As we noticed when reviewing our fact table from AdventureWorks, we're bringing in 3 date columns for order date, ship date, and due date. These are 3 separate attributes that belong to each record in the fact table, and they can be linked back to the dim date table whenever we want to analyze our sales data along different time frames like monthly sales, weekly sales, quarterly sales, and so forth. The problem is that we have 3 date columns on the fact table, but only 1 date dimension in our model. If we want to analyze our sales data by totaling sales based on which month they shipped in, we need the ship date column to have a relationship to dim date. But if we also want to total sales based on which month they were ordered in, we also need the order date column to have a relationship to dim date. It is possible to create multiple relationships between 2 tables in a Power BI data model, but there's a big limitation. You can only have 1 active relationship at a time. You cannot have multiple active relationships between 2 given tables. Instead, you need to create inactive relationships, which are represented in our model view by a dotted line connecting the tables, like you see here, while the active relationship is represented by a solid line. In this situation, the active relationship is your default relationship, whichever relationship you want to use the most when analyzing the data. If you want to analyze your sales data by any of the inactive relationships, it takes a little extra DAX to make that happen. Actually, scratch that. It takes a lot of extra DAX to make that happen. Specifically, there's a function called useRelationship, which can be used to override your model's default relationship and tell DAX to calculate using an inactive or non-default relationship. This is an extra step that you must take when working with inactive relationships, and I've never been a big fan of it. The big reason is that it requires us to multiply the number of measures we need to maintain. For example, if you want to analyze sales data by an inactive relationship, you need to write separate measures to calculate those sales figures by employing the useRelationship function. So if you have 10 measures that analyze sales data based on the default relationship, which we'll assume is the order date, then we'll need to create 10 more measures that calculate based on ship date, and then another 10 measures that calculate based on due date. This is less than ideal because it gives us a lot of DAX that we need to maintain, and it's probably more complicated than it needs to be. However, there is a much better alternative, and it comes to us from the world of dimensional modeling. There is a concept known as a role-playing dimension, which is any single dimension table that can be referenced multiple times by a given fact table. If you think of our dim date table as a role-playing dimension, there are 3 roles that this dimension can play in the context of our reseller sales fact table. It can play the role of order date, the role of ship date, or the role of due date. From a practical standpoint, what this means is that we need to create a separate table in our data model for each of these 3 roles. So instead of having 1 single date dimension like we currently have, we'll end up with 3 different tables. They will all be pretty much identical to each other, except for perhaps their column names, but each table will play a different role in our data model, and they will each have their own independent relationship to the fact table. So, let's walk through how to implement a role-playing dimension. We will return to Power Query, and the first step I'm going to take is I'm going to find our dim date table, and I'm going to right-click and deactivate it. Next, I'm going to rename some of the columns in dim date. I'm going to start with the full date alternate key, which I will just call date. Then I will find English day name of week and rename that to day. Then I will find English month name and rename that to month. Then scroll to the right, find calendar quarter and rename that to just quarter, and then calendar year and rename that to just year. Now what we're going to do is we're going to reference the dim date query 3 times. So right-click on dim date and go to reference, and then do it again, reference, and then do it again, and reference. Now let's rename each of our new queries to correspond to the 3 dates on our fact table. We need one for order date, we need one for ship date, and we need one for due date. Now, in a situation like this where you have 3 tables that have identical column names, you want to do what's known as creating self-describing column names. A self-describing column is one that has a name that pretty much tells you exactly what it is. In this case, we have dates and days and months and years, but they all belong to a different table. So what we want to try to do is rename every single column in these 3 tables so that they now say order date key and order date and order day number of week and order day and so on, and ship date and ship day number of week and ship day and so on and so on. Now, that sounds really tedious, right, to just go through and manually rename every single one of these. But fortunately, there's a shortcut that I'm going to show you. So we're going to go up to our Power Query formula editor, and I'm going to click the little FX button right here, which is going to add an empty step. In here, I'm going to remove this little reference to source, so we just have an equal sign. Then I'm going to put table.transform column names. And it looks like it wants to add a little extra table on here, table.transform column names. That's not what we want. So get rid of the table, just make it table. Now, open parenthesis, we're going to do a number symbol and then double quotation marks, and this is going to have the name of the previous step in our query, which is source. Then on the outside of the second quotation mark, put a comma and then the word each, and now we're going to start a new Power Query function called text.insert. This will have its own parenthesis to open the arguments that we'll enter in here, and then we need to set exactly what it's going to be affecting. To do that in Power Query, there is a shortcut. I'm just going to put in an underscore, then comma. The next parameter is the offset, which is going to be 0. We're telling the function to start at the beginning of each word, so 0, and then another comma. And then finally, we're going to specify what text we are inserting. In this case, since this is the order date query, I'm going to put in the word order. Then I'm going to click the check mark to commit the formula and watch what happens. Every single column in our query has now been updated so that the column name begins with the word order. So now we can take this formula, select it, and copy it, then come down to the ship date query, hit the FX button, replace everything inside of there, and we're going to put in the word ship. Commit that formula, and now everything has the word ship in front of it. Now let's go to due date and do the exact same thing. FX, replace it, and do. Commit that, and ta-da. Just like that, shortcut to replace all of those column names. Now let's hit close and apply and return to our model. Once the model is done loading, we can see our tables are now in our model view. However, they're kind of off to the side, so I'm going to drag them over and maybe resize them a little bit. I'm going to move measures over here. Let's wrangle this guy and bring him over here. And there we go. We have ship date, order date, and due date. Our model doesn't really look like much of a star anymore, but that's okay. And with that, we have created role-playing dimensions in our model that will allow us to analyze our reseller sales data by either due date, order date, or ship date. The main downside to using a role-playing dimension approach is that, as you can see, we have duplicated data in our model because we've added 3 different dimension tables. That means our data model will require slightly more storage. However, the keyword there is slightly, because these date dimension tables that we'll be adding are not nearly big enough to have a performance impact on our report. Now, we're not done with these tables just yet. In our next video, I will introduce you to the concept of time intelligence functions in DAX, which requires us to have these date dimension tables in our model. Time intelligence functions are some of the most powerful functions in the DAX language. They allow us to calculate measures across various periods of time, which means you can use them to calculate year-to-date totals, or month-to-date, or quarter-to-date. You can use them to perform period-over-period analysis, such as calculating year-over-year, month-over-month, and week-over-week. You can even use them to calculate opening and closing balances. All it takes is adding a date table to your model and sprinkling in a little bit of DAX. Using time intelligence functions requires us to add at least one date table to our model in Power BI. Now you might be thinking to yourself, hey, sounds good. We've already added 3 date tables, right? Well, sort of. In our last video, we added our 3 role-playing date dimension tables, but in order to use these as part of our time intelligence functions in DAX, we actually need to perform a little clerical task, if you will, on each of these tables. We do this by selecting each table in our model, going to the Options menu, selecting the option to Mark as Date Table, and then this will open a window where we will need to select whichever column in the table we want to use to identify all of the unique dates. On the Order Date table, that is our Order Date column. Then we click OK. Now, this has been set as a date table, and we need to repeat this for all 3 of the date dimensions in our model. So, mark as Date Table for due date, and mark as Date Table for ship date. The reason we do this is to explicitly tell our data model that these tables are to be used for time intelligence. Identifying the date column itself acts as a way of marking which column contains the unique dates that are the core ingredient of time intelligence functions. Once this is done, we're ready to begin defining our measures in DAX. So, I will start by going to our Measures table, and we'll create our first measure. This will be our total sales measure, which will act as the basis for all of our other measures. And we'll just simply sum the sales amount from our fact table. Once we've committed the formula, then let's make sure to go to our Measure Tools, which in this case in the model view we can find here in the Properties panel, and make sure that it is formatted the way we want. I'm going to format it as currency at 0 decimal places. Now let's take a look at the results. We'll go to the report canvas. I'm going to create an empty table, and then I'm going to go to our order date table. I'm going to add order year, order month number of year, and total sales. Before we go further, notice how our month names are sorted in alphabetical order right now. For instance, if we start at 2011, we begin with August, then December, January, July, March, May, November, and so on. If we go down to 2012, we see April, August, December, February, January, July, and so on. This is one of those things that often happens with text columns in Power BI. You want to sort them a specific way, but Power BI defaults you to alphabetical sorting. We need to find a way to override alphabetical sorting and tell the model to instead sort this particular column by each month's numerical placement, such that January comes first, then February, then March, and so on. The way to do this is using the Column Tools tab in Power BI Desktop. Simply select the column that you want to modify, which in this case is Order Month. Then go to the ribbon, find the option to Sort by Column, open the menu, and then pick whichever column you want to sort by. In this case, we will use Order Month Number of Year. This feature allows us to tell a particular column to override its default sorting, and instead sort itself by another column in our model. The column that you choose to sort by needs to have the same uniqueness as the column that you're looking at. That means there needs to be a perfect one-to-one relationship between these 2 columns in your date table. The month of February should always be equal to the number 2, March should always be equal to 3, April should always be equal to 4. Hopefully you get the point. Now once this attribute is set, notice that our table has automatically updated and the month name can now be sorted in descending or ascending order as needed. If we go to 2012, we see January, February, March, April, May, June, July, and so on. So now we're no longer alphabetically sorting our months. Instead, we're sorting based on the value of the month number column, which means we can probably take the order month number of year out of our table now. We don't need it. Now you've probably noticed that we have some months missing from our data. Looking at the year 2011, we seem to be missing February, April, and June. We'll come back to that in a moment. It just looks like there were some months in the AdventureWorks data warehouse where our sales team did not make any sales. Now let's define our first time intelligence functions in DAX. Our goal is to define a measure that calculates the year-to-date sales total. Year-to-date sales is the sum of the sales amount from the start of the calendar year, meaning the total of all sales made since January 1st of a given year. In effect, it gives us a running total, which can be helpful for visualizing the pace of our sales growth. First, I'm going to go to our placeholder column on the measures table and hide it. Then I'm going to go to the measures table and start our new measure. Fortunately, this one is really easy. We're going to call it total sales YTD. In the comment, we will call this the cumulative sales total for a given year. And then we'll start by writing total YTD, open parenthesis. Then we'll put our total sales measure in the first argument, then a comma. Then we need to define the date column that we want to use. In this case, we're going to use order date. So I'll select that one, then close parenthesis, and hit enter to commit the formula. Now let's change the formatting to make sure that it is currency and that we are doing 0 decimal places. Let's plot this in our table and look at the results. First of all, notice that we can now see February, April, and June of the year 2011, those 3 months where our teams didn't log any sales. Although the total sales column is empty for those months, our total sales YTD column shows the running total of sales starting in January. Then we add another $2 million in sales starting in March, which bumps our YTD total up to $3.5 million. Then no more sales in April, but we get a huge sum of $4 million in sales in the month of May, which hurls our YTD total up to $7.5 million. If we go all the way down to December, we can see that we end the year with just shy of $18.2 million in total sales. Then, if we scroll down to 2012, the YTD total resets for the new year, and we add $3.6 million in fresh sales in January. So this is the beauty of the total YTD measure. With one quick line of DAX combined with our date tables, we can generate these kinds of yearly running totals. Total YTD also has 2 companion functions. Total MTD will give you the month-to-date totals if you want to track sales starting from the first of each month, and Total QTD will give you quarter-to-date totals if you want to track sales starting from the first day of each calendar quarter. Let's use Total QTD and see how that looks. Go to the Measures table, define a new measure. Its name will be Total Sales QTD. We'll call it Get Quarter-to-Date Sales in the comment, and then we'll type in Total QTD, open parenthesis, put in our total sales measure, comma, and then once again, we will use the order date column. Close parenthesis, enter to commit. Let's make sure it's formatted, and then let's add it to our table. Notice how the QTD measure creates a running total across each quarter of the year, with 3 consecutive months grouped together, and then the running total resets at the start of the next quarter. Next, let's remember our requirements. Brian, the Vice President of Sales, asked us to also get previous year sales. He wants us to compare a given year's sales totals to the year that came before it, because he wants to see whether our salespeople are improving on their performance year over year. This kind of analysis, where we compare the results from one unit of time to the results from the previous matching unit of time, is known as period over period. In this case, Brian is asking us for year over year, but we can also calculate month over month, quarter over quarter, even week over week. We've actually done something like this already in weeks 1 and 2, where we used the calculate function in DAX to compare previous year amounts to current year amounts. But time intelligence functions make this scenario even easier than that was, because we've got these amazing date dimension tables in our model. So let's define our next measure. This one we will call Total Sales PY, which stands for previous year. In the comment, we will say get total sales for previous year, and then the formula will be calculate total sales, and then we will add a comma, and we'll start the same period last year function, in which we will put the order date into our argument, then close out our parentheses and hit enter to finish. Once again, make sure that the column is formatted the way you want it, and then we'll plot it in the table. And if we look at December 2011 in our table and pan right to the total sales PY measure, it displays the total sales amount from December of 2010. Effectively, what the same period last year function does is take each date in our date table and look backwards to the previous year, getting all of the dates from that year that fall under the same period, which is, in this case, the month of December. So it looks back from December 2011 to December 2010. Then it sums the total sales for December 2010 and returns that amount. That's a fairly complicated thing it's trying to do, and Power BI can perform this flawlessly with just a single line of DAX and a date table. Let's use time intelligence functions to do one more variation on this. The VP of Sales wants us to compare the YTD sales from this year to the previous year's YTD sales. We already have a total sales YTD measure that gives us the YTD sales for a given year, but we also need the ability to look backward and retrieve the previous year's YTD sales. This will allow us to take the running total of one year and compare it to the running total of the previous year. I'm going to expand my table a little bit, then go to the measures table and start our new measure. This one we will call total sales PY YTD for previous year, year to date. In the comment, we will say get total YTD sales from the previous year. And then we will calculate this as total YTD, but we'll use the total sales PY measure this time, and we will once again use our order date column. Then enter to finish the formula, and let's make sure it's formatted correctly, and then let's add it to our table. Now, this is great. We're getting running totals and year-over-year amounts for every year and every month in our date table. These are some great examples of relatively simple time intelligence functions in action. I personally love working with time intelligence in DAX because they basically act as shortcuts to performing what would otherwise be fairly complicated aggregation. Time intelligence functions really are one of the most powerful tools in your DAX toolkit. Later in this week's lessons, we'll use these measures to create some really interesting and insightful visualizations. However, we still have some more data modeling work to do in DAX, so let's continue with that in our next lesson. So far throughout this course, you've had me telling you how to write the various measures that we've written in DAX. This is how you've hopefully gotten to understand how different functions like calculate work, or how variables work, or how comments work, and so forth. But there will come a day very soon when you finish this course and you won't have me around anymore to tell you how to write a particular measure. So maybe I should take a few moments to show you some more tools that are baked into Power BI Desktop that can help you write measures when you're not sure how to get started. Welcome to the world of quick measures. You've probably noticed the Quick Measure button hanging out on our ribbon right next to the New Measure button, but we haven't used it so far in this course. So let's try it out and see what it does. Clicking the Quick Measure button opens a new pane or panel on the right-hand side of Desktop, where it explains that it will try to build measures for us in DAX if we just feed it some more information. There are two options to choose from: Calculations and Suggestions with Copilot. Copilot is relatively new. Microsoft just announced it earlier in 2023, and it's their way of embedding generative AI into the experience of Microsoft Excel, Microsoft Word, and yes, even Power BI. Think of this as sort of like ChatGPT Microsoft Edition, but it's embedded in Power BI Desktop. If you give it some words, it will interpret what you mean and spit out a DAX measure that tries to meet your requirements. Now, the Calculations tab has been around for years. It simply gives us a drop-down menu of quick calculations that we can do, where each calculation has an interface where we can add inputs, and then Power BI Desktop will convert those inputs into a measure. It's basically a way to write DAX without actually having to write any DAX. Our goal for this video is to create a year-over-year sales growth measure using the measures that we already created in our previous lessons. However, because we're super lazy and we've had enough of writing DAX for one day, we've decided to have Power BI do the work for us using quick measures. From the drop-down menu, find and select the option under Time Intelligence that says Year-over-Year Change. This will present us with three inputs for our formula. We need a base value, which is the measure we want to calculate. Then we need to provide it with a date column so it knows over what period it should try to calculate the change. And then it needs the number of periods to look back in order to calculate the change. So if we input the number 1 here, it will look back 1 year. If we put 2, it will look back 2 years. Our mission is only to look back at the previous year, so we'll leave this as 1, but we need to fill out these other inputs. We will add our total sales measure to the base value area, and then we will add our order date column to the date area. Then we can click the Add button. After we click the green Add button at the bottom of the pane, a new DAX measure will appear in our data model. In this case, it was added to my DIM employee table. And we can see the DAX formula inside of our formula bar. Its title is Total Sales YOY%. It starts with a variable named prev-year, in which it calculates total sales, but it uses the dateAdd function, which is another type of time intelligence function, to subtract 1 year from the order date. Then, underneath the return on line 3, it runs a simple divide function. It subtracts the prev-year sales from our total sales measure, and then it divides the result by the prev-year sales. So, as we can probably tell, this will give us the percentage growth rate from the previous year to the current year. The only thing I don't like about this quick measure is that it doesn't give us an alternate result to use in case we encounter a divide by zero situation. So I'm going to modify the formula by adding a comma 0 at the very end to account for that. Then I will commit the change. Then once we're done, let's just make sure that the measure is formatted the correct way. It is a percentage with 2 decimal places, which looks good to me. Now, to test this out, I'm going to use a blank report canvas. I'm going to add a matrix to the report canvas. In the values section, I will add our brand new total sales YOY% measure. In the rows, I will put our order months, and in the columns, I will put our order years. Then I'll also put total sales on the values area as well, so we can see sales in dollars and in percent growth from the previous year. Then, to see an example of the sales growth, if we just look at July of 2012, we see a 234% growth from 713,000 in July of the previous year to over 2.3 million in July of 2012. So that's how you can use quick measures to speed up your Power BI development and help you write measures when you're not sure where to start. You should also take some time to experiment with the Copilot feature and see what results that gives you. Going back to our requirements, Brian, the Vice President of Sales, wants us to create a dashboard with 3 specific features. First, Brian must be able to see all sales managers and sales reps in his department. 2, sales managers should only be able to see their own data, plus the data of any sales reps who report to them. And 3, sales reps should only be able to see their own individual data. From a dataset standpoint, this means we have to find a way to filter all of our sales data depending on who is viewing the report. If Brian is viewing the report, he can see everything. But if Linda, one of our sales reps, is viewing the report, we need a way to determine that it is her looking at the report and then automatically filter everything based on that fact. In Power BI, this kind of functionality is known as row-level security, or RLS, and it is a key aspect of data modeling. This is a topic that definitely comes up on the Power BI Data Analyst certification exam, because Microsoft wants to make sure that you know how to secure your data appropriately. If you have a Power BI report that displays payroll information, can you imagine how much drama it would cause if you didn't have row-level security on that model so anyone in the company could look at anybody else's salary data? I mean, that's just one extreme example, but I'm sure you can think of plenty of scenarios where row-level security could be extremely useful to you as a Power BI developer. The data model provides us the avenue to create row-level security. The relationship from the DIM employee table to the fact reseller sales table is one-to-many, with a single direction filter that runs from the employee dimension to the fact table. That means if we can find a way to filter the employee dimension, that filter will travel down the relationship and filter the fact table as well. In the model view, the row-level security features are visible in this section labeled Security. In here, you'll find 2 buttons, Manage Roles and View As. The Manage Roles feature will give us everything that we need to set up our filtering, while the View As feature will let us actually role play as one of our employees to test the row-level security and verify that it works correctly. So, without further ado, let's click on Manage Roles to open our row-level security editor. Once the RLS editor is open, let's examine everything from left to right. On the left, we have a Roles column with a button to add new roles. To the right of that, we have a column that shows all of the tables in our data model. If we click on a table like dim product, the filter data section to the right gives us an interface where we can add and remove filters to that table. For example, if we want to create a role for employees who should only have access to sales data about blue bicycles, we can create one filter based on the product category name and set it equal to bikes, and then create another filter based on the product color and set that equal to blue. Of course, we're not here to do this exactly, because nobody wants to look at just blue bikes. We want to filter the data by our employee attributes, right? So, how can we do that? First of all, I'm going to select both of these test filters and delete them, and then I'm going to go back to our first role that we created, double-click to rename it, and I'm going to call it Sales Rep. Now, the key to filtering the report dynamically based on who's looking at it is to use a particular DAX function called user_principal_name. This function reads the user account of the person looking at the report in Power BI and returns that account's username formatted as an email address. So we're going to create a filter for our sales reps that filters the dim employee table by comparing each person's email address to the output of that function. Now, I found that switching to the DAX editor in this window is advantageous for situations where you need to write dynamic formulas like the one I just described. So let's select the dim employee table and then switch to the DAX editor. And here we'll write a very simple formula. Email address with two equal signs is equal to user principal name. Then add a open parenthesis and close parenthesis. Make sure that the email address column is in between square brackets like you see here. And that's it. Let's click the Save button. And then let's create another role called Sales MGR for Sales Manager. Now this filter is going to be a little bit more complicated because we need to filter based on multiple conditions. So I'm going to type in supervisor email is equal to user principal name, open and close parenthesis. Then I'm going to put in two vertical pipes, and now I'm going to say email address is equal to user principal name with an open parenthesis and close parenthesis. So we're telling DAX to filter all dim employee records where supervisor email equals user principal name, or where email address equals user principal name. This will allow us to retrieve not only the employees for a given sales manager, but also the sales manager themselves. Finally, there's the VP of Sales role. I'm going to go in and type in VP of Sales, and that's really all we need to do. There's nothing we need to do with this because Brian needs to be able to see all of the sales managers and sales reps, so there's no filtering necessary. We can either delete this role, or we can just leave it here. Or we could give it another name like Sales Admin and use the Sales Admin role for not only the VP of Sales, but also any developers or IT admins who might need to troubleshoot the report sometime in the future. Now let's click the Save button again and then close the RLS editor, and let's try out our new feature. We'll go to the report canvas and we'll add a new table where we'll add several columns from our dim employee table. Once our table is created, we can go to the Modeling tab on our ribbon and then click the button to View As. This pop-up window that you see here gives us a simple checklist, and we can see the three roles that we created: Sales Manager, Sales Rep, and VP of Sales, plus this other option that says Other User. To test RLS, we need to select both the Other User option and the name of one of our custom roles. The reason we need to select Other User is because if we don't, it's just going to use our username, and we don't want that. We want to impersonate a different user, one of the sales reps who works for AdventureWorks. So we'll select Other User and Sales Rep, and then I'm going to put in the email address of a sales rep that we want to use for testing. This allows us, as I mentioned a second ago, to impersonate that user, putting ourselves in that person's shoes so we can see what the report would look like to them. So I'll put in Linda Mitchell's email address, which is linda3@adventure-works.com. Then we click OK. Our Power BI data model will put our filter in place, and the table now only shows Linda's data. Not only that, but we have this yellow banner at the top of the report canvas that tells us we are currently viewing the report in the sales rep role impersonating Linda Mitchell. When we're done testing, we can click the Stop Viewing button to exit this mode, and now we can see all the data again. Now let's try one of our sales managers. Click the View As button once more, then select Other User and Sales Manager, and this time we'll use Amy's email address, which is amy0@adventure-works.com. Then click OK. Now, when we look at our table, we see that we have not only all of the sales reps who report to Amy, but also we see Amy herself. When you publish a Power BI report to the cloud, you'll be able to configure which users in your organization fall under which roles. You can use either individual users or security groups to assign different accounts to the various roles that you create. This makes it so that when one of your users runs a report from the Power BI cloud, you don't need to do any of the view as stuff that we just did. Instead, it automatically reads their identity based on the account that they used to log into the Power BI cloud, and it filters the data accordingly using the row-level security against the data model. In Power BI, there is also a concept of object-level security, or OLS, which allows us to selectively show only certain tables or columns in our data model. That's a pretty advanced scenario, so we won't cover it in this course. Also, as of now, in July 2023, object-level security can only be configured using an external tool like Tabular Editor. It can't be done with Power BI Desktop. Okay, that's row-level security in Power BI Desktop. Our sales data model is almost complete. Going way back to the start of week 1, when we were first examining Power BI Desktop, I asked you to turn off a little feature in our global settings called Auto Date Time. And I promised at the time that I would explain later in this course why I asked you to do that. Well, in today's lesson, I will finally deliver on my promise. I'm here to talk a bit more about the Auto Date Time feature and why I recommend that you should turn it off in your reports. Now, this lesson is more of a demonstration and lecture, so there's no need for you to do this with me. You can just watch if you'd like. To start, I have a brand new empty report, and I'm inside of the report settings where I'm on Current File Data Load Settings. I'm going to enable Auto Date Time and click OK. Now I'm going to open up Power Query and I'm going to put in some dummy data. I'm going to go to Enter Data, and then I'm going to manually type in some data that I want. So column 1 will be name, column 2 will be hire date. First person is Jake, then Amy, then Rosa, then Charles. And we're going to call this employees. Now let's click OK. And we've loaded in our data. Now, the reason I'm doing this in Power Query instead of Power BI Desktop is I want to verify that this is a date column. Once I've verified that, I'm going to click Close and Apply to load this into our data model. Once the data model is loaded, I'll switch over to the data view where we can see we only have one table that consists of these 4 rows. Now let's take a look at Tabular Editor to see what Auto Date Time actually does behind the scenes in our data model. Once Tabular Editor is open, if we open up the Tables node on the left-hand side, we will see that there are in fact more tables in our data model than just the Employees table that we created. In particular, there's this local date table right here, which has a randomized GUID at the end of it. And if you remember, GUID stands for Globally Unique Identifier. If we expand this, we see that the local date table consists of several columns and a date hierarchy. And if we select the local date table, Tabular Editor will show us a DAX formula in the upper right portion of our screen. This formula is used to automatically generate this local date table. And if we look through each of these columns as well, like year, month number, month and quarter number, we can see that each of these also consists of a DAX formula that is used to generate this data. So you can hopefully see that this table is very similar to the dim date table in our AdventureWorks model. It's a date dimension, except instead of this table being queried from our data warehouse, it's actually a calculated table that is generated through DAX. These formulas are automatically generated based on the existence of date columns in your data model. Now I'm going to take this DAX from Tabular Editor and copy it, and then I'm going to close Tabular Editor, go back to Power BI Desktop, and I'm going to click the New Table button here and paste in the results here. I'll call this table calendar and then commit the change. So this is what the first column of that local date table actually looks like inside of our Power BI model. We have dates starting at the year 2010 and going all the way to December 31st of 2023. When we look at the DAX formula more closely, it's using this calendar function, and then it's feeding in two arguments. The first argument finds the minimum year of the hire date column, and then it gets the first day of the first month of that year. The second argument gets the maximum year from our hire date, and then gets the 31st day of the 12th month. So this allows us to create a table automatically that spans from the first day of the first month of our earliest year to the last day of the last month of our latest year. So here's the thing, if you have auto date time enabled, Power BI will automatically create one of these hidden tables for every column in your model that is formatted as a date. If we think back a few lessons, these hidden tables are basically role-playing dimensions, right? So this acts as a sort of shortcut to create role-playing date dimensions in our model. What could go wrong? Well, let's look at what could go wrong. If I minimize Power BI Desktop and then find the file I'm working on and look at its properties so I can see its file size, we can see that it's only 78 kilobytes in size. It's absolutely tiny. Let's add another employee whose hire date is March 1st of 1980. Then we'll update the model and look at the file size again. So I've reopened Power Query. I'll go to my source step, click Edit, and then I'm going to add another employee named Raymond, whose hire date is March 1st of 1980. Click OK. Make sure the column is still formatted as a date, and then click Close and Apply. When the data model reloads, notice now that the calendar table that we have visible here in our model begins at January 1st of 1980 and now spans all the way to December 31st of 2023. If we save our PBIX file and then go back to the desktop, right-click on the file and view properties, our PBIX file has now gotten bigger. We've added 30 more years worth of data, which has caused our file to grow up to 155 kilobytes in size. Now, so far, this is still a trivial amount of data. But suppose somebody makes a mistake in our hypothetical HR system. They're adding a new employee to the system, but instead of putting the employee's hire date as 2023, they accidentally enter it as 1023. We'll call this new employee Methuselah, and we'll give him a hire date of February 5th, 1023. And if you're a follower of one of the Abrahamic religions, hopefully you're getting that reference. Now I'm going to click OK, then Close and Apply, and let's watch what happens now. Now our calendar table starts at the year 1023, and if we save the file, then minimize Power BI Desktop, right-click on the file on our desktop, and go to Properties, we can see that the file size has now ballooned up to 8 megabytes. All of that thanks to one mistyped digit in our data model. Somebody typed the number 1 when they should have typed the number 2, and our data model just exploded in size as a result of that error. Now, I probably don't need to demonstrate what happens when we have multiple columns with bad data like this. At this point, you can probably guess. It will only multiply the issue. And these kinds of occurrences can cause performance issues in Power BI when you're trying to filter on dates, because the tabular model has that many more rows that it needs to scan when it's filtering and sorting data. So the more date columns you have in your model, the more of these tables that will be added to your model using the auto date time feature, and the more storage that data will consume. This illustrates that it's always important to find and clean up messy data. In this course, we've typically relied on column profiling in the Power Query editor, but that's not always a foolproof approach because the Power Query editor only loads a small preview of your data when you're doing transformations and profiling, so you may still miss a lot of bad rows. You may not find out this bad data exists until you load everything into your data set and you suddenly notice that your report performance is slow or your PBIX file is several hundred megabytes in size. But once you discover this, you can easily fix the issue by either correcting the data in the data source or by using Power Query's features to replace the bad data. Typically, you should err on the side of correcting the data in the data source, because you never know when someone else on your team might run into the same issue. Another thing to note is that not all date columns in your data model need to be analyzed. In our AdventureWorks data model, we're loading the hire date for each of our salespeople into the model, but we didn't create a date dimension to connect to that column. Why? Well, because we're not interested in analyzing hire dates for this dashboard. We want to analyze each person's sales history based on their order dates, ship dates, and due dates. The date on which a person was hired is not a component of that analysis. And the same could be said of each person's birth date, as another example, if we had included that in the model as well. Employee hire dates and birth dates are not relevant to our sales analysis, so we don't need to create date tables for them. However, if we had turned on auto date time for our AdventureWorks data model, we would be saddling our data model with those extra date tables based on hire dates and birth dates, but those tables would serve no purpose because they don't fit into our analysis. That means we'd have two tables taking up space in our model when we don't need them. If you turn off auto date time by going into your report settings, well, what are your other options? Well, first of all, in our current situation with AdventureWorks, obviously we just loaded a date dimension from the data warehouse. However, if you're building a project where you don't have a data warehouse with a pre-built date dimension, you can build your own date dimension tables using the calendar function in DAX to create a calculated table, like I showed you a moment ago. Or you can use a custom script in Power Query. Any of these options will give you way more control over how many date tables you want to create and how big they should be. The official guidance from Microsoft states that we should use auto date time when you have simplistic model requirements in relation to time. What they're really saying here is that you should avoid using auto date time when you're running a model that has a lot of date columns in it, because that's going to generate a lot of these hidden tables. Microsoft goes on to say using this option can also be convenient when creating ad hoc models or performing data exploration or profiling. So Microsoft is telling us that it's okay to use auto date time, but you need to be selective about when you use it. For small projects and prototyping, using auto date time is probably fine, but as soon as you start developing a data model that you plan to put in front of end users, you need to think much more carefully about your design. Do you plan to use any time intelligence features in DAX? Do you plan on aggregating your data by years, months, or weeks? Do you want to know if certain events in your data fall on a Monday as opposed to other days of the week? Does your organization use a fiscal year that is different from the calendar year? If the answer to any of these questions is yes, you need to add a date dimension to your data model, and you should avoid using auto date time to do it. Auto date time is the lazy way of adding date dimensions. It's the easy way, the one that requires the least amount of thought. But it's also the way that gives you the least amount of control. And as you can see, that can have some unintended consequences. You can end up with more date tables than you need and with more rows than you need thanks to bad data. And both of these can negatively impact the performance of your report. That's why when I'm interviewing people for Power BI developer jobs, I like to quiz them on their knowledge of the pros and cons of using this feature. Knowing how auto date time works and the potential impact it can have on your data model and your report performance is another one of those tidbits of knowledge that separates the Power BI experts from the Power BI hobbyists. Okay, it took us several lessons to build our data model for AdventureWorks, but we have built something really great here. We've got a star schema that has role-playing date dimensions in it. We've got time intelligence measures in DAX that will allow us to perform some really cool calculations like year-to-date and year-over-year analysis. We've even got row-level security, or RLS, so when our users run this report in the Power BI cloud, they will only be able to see the data that they are entitled to see. Now that we've modeled our data, let's take the next few lessons to build a fully functional, good-looking Power BI report. We'll start by building out some basic stuff for the 2 report pages that Brian, our VP of Sales, requested us to build. This is where it might be helpful to refer yourself back to the 2 very professionally drawn sketches that Brian provided us with. And these were totally drawn by Brian and not your instructor Pete, because Pete is a very gifted artist who would never draw something that looks this amateur. Okay, let's go back to the report canvas, and I'm going to start by taking page 1 and renaming it to Home. Then I'm going to format the canvas and add a background image. If you click the Browse button and go to your Week 3 exercise files, you'll find a subfolder named Images, where you will find a background image that you can use either in PNG or SVG format. It doesn't matter which one you choose. Also, you could just choose to use your own background if you want to. You don't have to use the ones that I'm providing. But I'm going to opt for the SVG background, set the transparency to 0, and that looks pretty good. Then I'm going to go to Insert and add an image, and I'm going to add our AdventureWorks logo. And I'm going to size it down a little bit and drop it in the upper left corner right here. Next, I'm going to add a table visual, and then drop it sort of front and center here in the report. And let's start adding some columns. Now, there's one measure we forgot to add in the previous lessons, so I'm going to select the measures table and click New Measure to create it. This measure is the total lifetime sales measure that Brian asked us for. So I'm going to type in total lifetime sales equals. We'll add a comment here that says get total sales for all years, then come down a line. And our total lifetime sales measure will say calculate total sales. Then I'm going to use the remove filters function to remove all filters from the order date, order year column. Then commit that formula, make sure it's formatted as currency with no decimal places. And now let's add total lifetime sales onto our table. And let's actually move it in front of the total sales measure by clicking and dragging it right there. Next thing we need to do is we need to add some slicers on here. So we're going to add a slicer, then going to go to the order date table and add order year onto the slicer. We'll format the slicer so that it is a drop down and single select. So you can only look at 1 year at a time. And I'll sort in descending order so that our slicer starts at 2013 and then goes down from there. Now when we look at our table, using our slicer filtered on 2013, the total lifetime sales column, as you can see, contains the total for each salesperson's sales across all years, but the total sales measure only contains the total sales for the year 2013. So let's go back and take a quick look at the total lifetime sales measure and explain a little bit better what this is actually doing. We're calculating the total sales measure using the calculate function, but we're using this remove filters function right here to override any filters coming from the order date table. That allows us to get the total sales for any employee regardless of the year in which the sales occurred. Okay, let's add some more slicers. I'm going to select my order year slicer, copy it and paste it, bring it down here, and then I'm going to replace order year with the dim employee sales group. Let's also make this one not a single select so that our users can select multiple regions if we're talking about Brian, the VP of Sales. Then let's copy that slicer, bring it down, and now we're going to use sales country. So go to the object editor and exchange sales group for sales country. Now our users can go in and select a particular country like the United States or Germany or Canada and get all of the salespeople associated with either the sales country or the sales group if we want to see all salespeople associated with Europe. Next, if you look at our table, you'll notice that our employees are being sorted alphabetically starting with their first names. So let's go to our dim employee table, and using one of the lessons that we just covered, we'll select the name column, then go to sort by column and use the sort name column instead, which will sort their names starting with last name, then first name. Now let's go to our insert tab. We're going to add a title. So add a text box. The next thing we're going to do is we're going to add another text box in the bottom left corner that explains to our user how to use this report. So we'll add another text box, and I'm going to say select a salesperson from the table on the right and click the See Sales Detail button to see their full sales data. Use the slicers above to change which yearly data is visible or to filter by sales groups and countries. Now let's create our second page. Click New Page. We're going to name this one Employee Dashboard. We will once again go to Canvas Background, hit the Browse button, and bring in your background image. Set the transparency to 0 so you can see it. And now we have an employee dashboard. Let's go to the page information, set the page type to drill through, and then turn off the Keep All Filters option. We will drill through from Employee Name column. Now let's create a new card visual at the very top. We're going to leave some room on the right-hand side for our employee photos to go. Then let's start adding some data. First of all, we will add employee name, title, hire date, phone, sales region, and finally, total lifetime sales. Now we're going to lay it out in a grid that contains 2 rows and 3 columns. Let's decrease the size of our callout values because right now they are absolutely enormous. So I'm going to pick Sego UI. Let's bring it down to 18. Now let's decrease the vertical spacing on all of these. And if we look at it, we can see that one thing we need to do is we probably need to reformat this hire date column. So let's go back to our data tab, select hire date, go to our column tools tab, and let's change the date format from this format, which is long date, to a short date. Now let's go through and rename each of these cards, because you can see that right now they're using implicit measures like first and earliest to return a lot of these values. But we don't need that extra information on there, so we can change the different labels. We'll go to the name and we'll set the label for that particular card to just be name. We will change first title to just title. And then total lifetime sales doesn't need to be changed. Now let's add icons to all of these. Let's also make sure to go to our size and style settings and turn off the background. So now we can see our beautiful background image behind the new card visuals. The last thing I'm going to do here is I'm going to add a little visual separator between the top part of our page and the bottom part of our page. I'll go to the Insert tab, find the Shapes menu, and I'm just going to add a straight line in here. Now notice that we automatically have a back button in the upper left corner of our page. I'm going to resize this a little bit so it's easier to see. And now we can hit the back button to return to our dashboard. Cool thing we can do here is if we right click on one of our employees like Michael Blythe, go to drill through and hit employee dashboard. Now we're looking at the sales data for Michael. Go back, sales data for Jose, drill through employee dashboard. All right, there's Jose's data. Now let's go back because the last thing I want to add before we close out this lesson is a drill through button. And you can see that I alluded to this in the comments that I added in the bottom left part of our homepage, where it says click the See Sales Detail button to see each employee's full sales data. Now I'm going to amend this language slightly. I'm going to change it from See Sales Detail to Go to Salesperson Dashboard. And let's resize that font to get it consistent. Perfect. And I'm going to resize the table a little bit to add a little bit of room at the bottom of the page for the button to go in. Now we're going to go to the Insert tab, find the Buttons menu, and then add a blank button to our report canvas. For me, it added it in the very upper left corner, so I'm going to bring it down. I'm going to resize it to make it a little bit taller and a lot wider. And I'm going to center it on the page like so. Now in our format settings for the button, the first thing I'm going to do is I'm going to enable the action settings. Then I'm going to open that. I'm going to change the type of action from a back button to a drill through button. And the destination will be the employee dashboard. Now let's set some additional properties for the button. We can do that under the Button Style menu, where we can choose between the default state, on hover, on press, and disabled. We're going to start with disabled, where I'm going to enable the text settings, open that up, and then I'm going to type in select a salesperson to enable. I'm going to make that font just a little bit darker so it's easier to see. And now our button says select a salesperson to enable. Now let's switch over to the default state and let's say go to salesperson dashboard. Now, if we select one of our employees from the table, like Jillian Carson, we can watch as our button text changes from select a salesperson to enable to go to salesperson dashboard. And now the button is enabled. So I can control click on the button, and now I'm looking at Jillian Carson's data on our employee dashboard. So let's demonstrate one more time. Select a salesperson to enable, then let's select David Campbell. Now it says go to salesperson dashboard, hover over, turns green. Actually, I don't like it without the border because it's a little bit hard to tell that there's a button there. So let's go back to the disabled state, then let's go down to fill, and instead of having a white or whatever very hard to see shade of color that is on disabled, I'm going to change this to something like a gray color. So now select a salesperson to enable, and enable. And let's do the same thing on default. Let's give it just a little bit of a color here, like that, so it's easy to see. I don't know. Fiddle with it and see what settings you like. I'm just going to leave it like this for now because I don't want to overthink this. But that's pretty much all that we need to do to set up a drill through button. And that's enough for this lesson. We've built out the basic structure of our report, which is to have a home page that acts as our starting point and which summarizes our employee data, as you can see. And then we have the employee dashboard, which will summarize the information about a given salesperson when we drill through from the home page. In this lesson, I'll show you how you can add images and interactive hyperlinks to your table and matrix visuals in Power BI Desktop. If you recall our business requirements, the VP of Sales wants to see each salesperson's photo inside the report, and they want to have a clickable link to email each person. So we'll plan on adding these features to both the home page and the employee dashboard. To do so, let's return to Power Query and navigate to our DIM employee table. And we'll start by creating a hyperlink for our email. Now, unfortunately, it's not as easy as just adding our existing email column to a visual in Power BI Desktop. We need to add a small prefix before each email address in order to get Power BI to recognize it as a hyperlink. So I'm going to select the email address column, go to Add Column tab, then I'm going to say Format, Add Prefix. When the box pops up, I'm going to type in mail to, all one word, with a colon, and then click OK. And we're done. This small tweak is all we need to do to create email hyperlinks in our report. We'll come back to this later and show you how to actually add them to the table. Until then, let's move on to the photos. You may have noticed that the Data Warehouse's DIM Employee table contains a column named Employee Photo. I asked you to bring it into this data model because this is what we need in order to actually display employee photos inside of our report. Each photo is encoded and stored in the database table as binary data, which Power BI can then convert into an image. But first, we have to do a quick transformation. Select the employee photo column, then go to Transform, and we're going to add another prefix. Transform, Format, Add Prefix, and this time type in data, image, /JPEG, semicolon, base 64, comma, and add an extra space on the end. Then click OK, and make sure that this is formatted as text. If you expand the column, you'll notice that the binary data has been converted into this format. Then I'm just going to rename this column as photo so it won't take up as much space on our table visual. Similar to the prefix that we added to the email addresses that allows those to be turned into hyperlinks, this prefix here will decode the photos for us when we add them to our report. Before we move on though, I want you to notice how this particular transformation has broken the fold in our query. I knew this would happen, which is why I chose to transform the photo data after I did the emails. If we go back to the inserted prefix step where we formatted our emails, we can see that query folding is still enabled in there. And if we scroll down, we'll find the SQL code that added the mail to prefix right here. If you're going to break the fold on a query like this, make sure to do it as far down in the recipe as you can, because you want to maximize the number of recipe steps that can take advantage of query folding. Once the fold is broken, it stays broken for the remainder of the recipe, which will degrade your data refresh performance perhaps earlier than you need to. Once the data model has refreshed, let's select our table, go to the object editor, add data, go to dim employee, and select our email column. Then let's drag it up and put the email between the name column and the sales group column. Now you'll notice that we have our transformed email addresses here, but they're not hyperlinks. So how can we turn these into hyperlinks? First thing we'll do is go to our data panel, select the email column, then go to our column tools, open up the data category menu, and select the web URL data type. This will format all of our email addresses as hyperlinks. Next, there's one more thing we can do, which is we can go to the format settings for the visual, then scroll down to URL icon, open that setting, and then turn on the setting labeled values. Once you do this, your email addresses are converted into small envelope icons, which allows you to free up more space on your report canvas. Now, if I want to email one of these employees, I can just click on the little envelope icon. I might get prompted to launch another application, and that's okay, so I will click the Allow button. And when I do this, I get an email that's automatically addressed to Linda. Awesome. Next, let's add their photos. Go back to the object editor, add data, then go to dim employee, and select photo. Once more, we're not getting the results that we expect. However, if we go back to our data panel, select photo from the list of columns, then once more go to our column tools tab and open up the data category menu, we have an option for image URL. Select image URL for that column, and presto, we've got photos inside of our table. Let's drag photo to the very top of the table before the name column, and now we can scroll through and see the photos of all of our salespeople. It's not often that you'll come across image data stored in a database because those binary columns in the database tend to slow down SQL queries. I think it's pretty common practice these days to store photos in a file system, either in the cloud or on premises, and then link to those locations from the database using URLs or network file paths. However, in this case, AdventureWorks gave us the ability to show how to add images and interactive hyperlinks when they're stored as data in your model. In our next lesson, we'll add photos to our employee dashboard page by introducing you to custom visuals in Power BI. Now that we've added our employee photos to the home page of our sales report, let's see how to do it on the employee dashboard. As you've already noticed, you can add images to table and matrix visuals very easily, but most other visuals in Power BI don't support embedding images like that. In some cases, you need to look beyond the core set of visuals that come with Power BI Desktop and instead rely on the greater Power BI community, because there are many awesome developers out there who want to improve Power BI, and some of them have done that by creating custom visuals that either improve upon the core visuals or they fill some gaps in functionality that the core visuals don't address. In our case, we want to add employee photos to the employee dashboard, where we'll only be looking at one employee at a time because it's a drill-through page. We could add a table visual to the page to accomplish this, but it will probably look weird because there will be only one row of data in it and there will be a column header at the top. If we can't think of another option from our existing list of core visuals, then we can try to find a custom visual instead. Fortunately, this is easy to do most of the time. Now, to get to custom visuals, go to your Insert Visuals menu, then scroll down to the bottom, and you should see an option to Get More Visuals. This is where you'll be prompted to enter your organizational email address. If your organization does not currently work with Power BI and you don't have a login to a Power BI environment, then you can just watch as I do this. Once you're logged in, what you'll see here is the Power BI Visuals Marketplace, the home for all custom visuals in the world of Power BI. Each of the tiles on this page is a different custom visual, and there's some basic information like the name of the visual, who developed it, and what the average rating is from the Power BI community. One of the first ones that you'll find is the Deneb visual, which is one that I am particularly fond of, so let's click on it and take a look at its details. On the next page, we get a description of the Deneb visual, as well as several screenshots that show us different examples of what we can create with this particular visual. We also see a little badge in gold that tells us that this particular visual is Power BI certified, which means that Microsoft has reviewed the visual's code to make sure that it meets their standards. I'll include a link below this video to the Power BI visuals documentation if you'd like to find out what the standards are and how you could potentially develop your own custom visuals for Power BI. This particular visual, Deneb, is one of the most popular visuals ever created for Power BI because it creates gorgeous data visualizations that are almost infinitely customizable. It's totally free, and it uses a JSON syntax that most people find pretty easy to understand. I've used it a few times in my career so far, and students taking this course on the verified track will have the opportunity to learn more about Deneb in week 4. Also, it's important to know that not all visuals are free. Some visuals are developed by companies or solo developers and sold on the marketplace, and their pricing details are visible on the detail page. There are several companies like MAQ Software, XViz, and Zebra BI that are especially well known and popular in the world of Power BI custom visuals. This particular example is from MAQ Software, and you can see that there is a Plans and Pricing tab visible, which if I click on it will show me details about the pricing options for this particular custom chart. If your organization has some budget money to spend on custom visuals, you should consider checking out everything that's available because you may find something that can really enhance your Power BI reports. Now let's go find a visual for displaying images. You'll find a search box towards the upper right corner of the marketplace, and I'm going to type in the word image and search. This Image Pro visual seems to have very good reviews, and I can tell that it's Power BI certified because it has this blue badge next to its name. I'll click on it to see its details, and then I'll click the blue Add button to add it to our report. Once it's added, we'll get a pop-up telling us that it was imported successfully. Then we can close the pop-up, go to our Visuals menu, scroll down to find Custom Visuals, and we can see it towards the bottom of the menu. Hovering over the icon will show us the name of the visual, where it says Image Pro by CloudScope, and it'll give us a version number. So let's add the visual to our page. Then I'm going to resize it and click and drag it into the upper right corner like so. Then for the image URL, I'm going to go to Add Data, Dim Employee, and add our photo column. Next, I'll go to Size and Style settings for this visual and turn off the background so we can see the photo superimposed on top of our background. Now let's use the back button to return to our home page, and then let's select a different employee from our list. We'll select Linda, then click the button to go to our salesperson dashboard, and now we see Linda's photo at the top of our report page. That's your introduction to custom visuals. I'll go ahead and give you a quick note of caution. Not all Power BI custom visuals are made of the same quality. There are some out there that aren't very good, either because their code isn't optimized or they're several years old and no longer supported by the developers who originally created them. There was one visual that I used for a few years that I really liked, but was eventually retired by its developer, and I had to find a way to replace it in all of the reports I had built where I had used it. The point is, there could be a lot of different reasons for a custom visual to not work well in Power BI. So what I always tell people is buyer beware. First piece of advice, always look for that Power BI certified badge on custom visuals because that tells you Microsoft has vetted the custom visual. Second, check the average review scores on the visuals and read the reviews to see if other developers have encountered issues with them. If you follow those steps, you shouldn't run into any issues. Anyways, spend some time exploring the Power BI Visuals Marketplace. I guarantee you'll find some interesting visuals in there that you can use in your reports. Okay, in this lesson, we'll finish the employee dashboard by adding our visuals to it. We'll stick with Linda here since her data is already selected on our drill-through page. Let's take another glance at the mock-up that Brian, our VP of Sales, drew up for us, and then notice where everything is situated. Then let's start with the first question. What are Linda's yearly sales? And we want to compare those yearly sales against the previous year's sales. So let's try building this using a bullet chart. Now, bullet charts are not a core Power BI visual, so you'll need to go to the marketplace to find them. Otherwise, you can try to create a fake bullet chart or something that looks similar by using a clustered bar chart visual. So I'm going to go to the marketplace and search for the keyword bullet. You can use the Microsoft bullet chart, but I don't really like it that much. I think it's not a very good visual, so I'm going to get this one by OKViz that I'm familiar with. I'm going to add that to my report. Now, let's add some data. In the category area, we are going to add our order year column. In values, we'll add total sales, and in targets, we will add total sales PY. Now our categories are not sorting chronologically, so I'm going to go to my visual settings, find the sort axis, tell it to sort by order year in descending order so that 2013 is on top. Next, I'm going to go to my format settings for this visual. I'm going to turn off the states option because I don't like the gray area that creates behind my bullets. Then I'm going to change the data colors. I've got a shade of green that I used for creating the icons on our new card visual. So I'm going to go to more colors, and in the hex code box, I'm going to paste in A9D18E, which is the hex code for this particular shade of green. And you can see that our bullet chart has now been updated so that it matches the color of our icons. The next thing I want to do is add a title that is dynamic based on which employee we are looking at. So to do that, I will go to our data panel, go to measures, and create a new measure. We'll call this new measure bullet chart title, and it will ask what are, and we'll use selected value, open parenthesis, dim employee name, close bracket, close parenthesis. Then we're going to use another ampersand. We'll use an apostrophe S, and then we will ask what are Linda's year-over-year sales? Question mark and close. Commit that formula. It's added to our measures table. So let's go into our format settings, go to title, go to conditional formatting, go to our measures table and select bullet chart title from the list and click OK. Now our chart asks us what are Linda Mitchell's year-over-year sales. Another way you could have done this that would have been kind of cool, bring in the employee's first name from our data warehouse and just have the first name in the formula. So instead of what are Linda Mitchell's year-over-year sales, you could just ask what are Linda's year-over-year sales. As a matter of fact, rather than talk about it, I just went ahead and did it. So I'm going to go back to my bullet chart and I'm going to change name to first name and then commit my changes. And now my chart's going to ask what are Linda's year-over-year sales. The only thing I'll change now is I'm going to add hyphens between year over year, so that looks a little bit better. Last thing, let's add a little gray border around this. Size and style, go to visual border, turn it on, change the color to a light gray. Adding that border just helps it match stylistically with our new card visual up at the top. Now let's add a visual that gives us some more context on these numbers. Let's add a matrix that gives our user the ability not only to see the yearly numbers, but also some of the monthly numbers. I'll go to the visuals menu, add a matrix, drop it in here. In the rows, I'll go to order date and add first order year, then order month. I won't add any columns, but under values, I will go to the measures table and I will add total sales PY, and our year-over-year percentage measure. I'll also add the total sales YTD measure just to fill this out a little bit more. Now let's also make sure that order year is sorted in descending order so it matches the ordering of our bullet chart. And then let's expand one of these years so that we can see that we have 2013, but we also have every month within 2013, and we have each month's total sales, the total sales of that month from the previous year, the total year-over-year sales growth expressed as a percentage, and the year-to-date total sales. Let's also do a little conditional formatting. Let's go to our total sales year-over-year percent column, conditional formatting, and let's add some icons. That ought to work. Hit OK. And now we have these helpful little indicators to let us know when the year-over-year sales growth was greater than or less than the year prior. Lastly, for a title, we'll just go in and call this Yearly Sales Summary. Now, the next question is, what are Linda's top-selling products? To answer this, I will do yet another matrix, and we'll open up our matrix, go to the object editor, and start adding data to it. We'll go to dim product, we'll start with product category, followed by product subcategory, and finally, product itself. In the value section, we'll add our total sales measure. Then, let's add a little bit of conditional formatting on this as well. Right-click on total sales, and let's add some data bars. And the hex code that we will use is A9D18E, which gives us the same green color that we were using earlier. Now we get some data bars on here, and we have an expandable matrix. Obviously, Linda seems to really excel at selling these bikes, and we can expand and see that she sells more mountain bikes than road bikes. And if we expand that category, we can find out which particular models of mountain bikes she sells the most of. Let's do a little bit of formatting. We'll add our visual border, give it that same silver gray color, and then we need to add another title. So at this point, if we start to add a whole bunch more titles, our measures table is going to get a little messy. So let's reorganize it a little bit. I'm going to go to the model view, find our measures table, and I'm going to select all of these measures that we created earlier for total sales, and I'm going to add them to a display folder, which I will call measures. This display folder property allows us to group measures and columns into folders inside of the table. It doesn't change anything structurally about the data model itself. It merely groups items into a sort of organization that can make them easier to find. So those will go into measures, and then I'm going to select bullet chart title and put that into another display folder called labels. Now, if I head back to the report view and look at our measures table, we can see that there are two folders within here, labels and measures. This is really helpful when you're working with a data model that has a lot of columns, and you can do this on any of your tables actually. If we go back to, for instance, fact reseller sales, if we wanted to group all of our key columns into a display folder, all we need to do is select all of them, like so, then pick the display folder, and let's call it keys. Now, when we return to the report view and go to our fact reseller sales table, we can see that all of our key columns are now inside of a display folder. Now, I'll say this, most of the time people will tell you to hide your key columns inside of your data model because your report users aren't going to actually want to display key columns. They're not really necessary, to be honest with you. So I actually recommend just hitting that little hide button on all of them and get them out of the way because you're probably not going to use them inside your report body itself. Anyways, back to creating our measure. Now let's go to our matrix, open up the title properties, go to conditional formatting, field value, measures, labels. Whoop, it's not there. I must have added it somewhere else by accident. Hit cancel. Let's go back, try to find it. Looks like I accidentally added it to dim employee, so let's select that, change the home table to measures. Let's go back to our data model. And once it's on measures, I'm going to add it to our labels display folder. There it goes. Now let's go back to the matrix, format settings, conditional formatting, measures, labels, and product matrix title. Click OK. And now our report asks us, what are Linda's top selling products? The next question, what are Linda's top producing regions or resellers? So we're just going to add another matrix on here. On our rows, we'll go to dim sales territory. We'll start with sales territory country and select region. And underneath that, we'll go to dim reseller and select the reseller name. Finally, in our values, we'll once again drop our total sales measure, like so. Now we can expand United States. We can see the different regions that Linda sells to. She's particularly located in the Southwest, it seems, and we can expand that to see the resellers that she primarily sells to. Next, select the matrix, go to Size and Style, turn on the visual border, and now we need to grab a title for this. So let's go back to Measures, go to our Measures table, New Measures. Commit that formula, go back to our matrix, title, conditional formatting, based off a field. Let's hope I got it right this time. There it is. It's on the right table. It's just not grouped under a folder. That's okay. Select reseller matrix title and click OK. And now it's asking us that question. Awesome. Go back to the model, and I'm just going to make sure that reseller matrix title is added to the label subfolder. And there we go. All right, last visual, last question. What are Linda's cumulative monthly sales year over year? That's what we're talking about here. So for this one, I'm going to select an area chart from our visuals menu. Drop that right here in the bottom right corner. Our x-axis is going to have months on it. So go ahead and go to the order date table, add the order month onto the x-axis. Then on our y-axis, we'll add two measures. First of all, we'll add the total sales PY YTD for previous year. Then we'll go back and we will add the total sales YTD. Now, in this particular chart, we want to emphasize the sales for the current year, which in this case is the year 2013. So what we can do is we can go back to our format settings, go to the lines section, find the series called total sales YTD, and we're going to change the colors to that same shade of green that we used earlier. Then we'll select our total sales PY measure. We'll change the line style to dotted. And if you notice that the measure is grayed out right here, what you can do is you can just drag that column on your object editor up to the top of the y-axis and it becomes enabled. So now I'm going to pick the color here and I'm going to go for a subtle little shade of gray. Actually, I'm going to pick a slightly darker color because I don't think that's showing up as well as I would like. That's better. Now what we have is a great chart showing us the cumulative running sales of the current year juxtaposed on top of the sales from the previous year. And now we can start to play around with this a little bit. But first, let's make sure that we've got our border added onto our brand new chart. And let's do a little bit of cleanup on the chart itself. I don't think that we need the y-axis title there, so I'm going to turn that off, and I don't think we need the x-axis title, so I'm going to turn that off. And that'll just give us a little bit more space inside of that visual. The last thing we need to do with our area chart is give it another dynamic title. And commit that formula. Now just go through the normal step of adding that to your area chart and you should get a result that looks like this. Now let's click our back button to return to our home page and let's select a different salesperson. Let's look at Garrett, go to Salesperson Dashboard. And Garrett looks a lot like Linda's data too, except he actually managed to beat his sales target in 2013. He sold 1.2 million in 2012 and in 2013 came out, blew that open with 1.43 million. So good job, Garrett. And with that, we're pretty much done with our employee dashboard. You now have a great product here that you can put in front of the VP of sales, the sales managers, and the sales reps themselves that allows them to go in and look at their own data or the data of the people that they manage and interactively zero in on the particular sales figures year to year that matter to this company. I think that's pretty awesome. So that will round out our completion of the employee dashboard. Over the next couple of videos, we might do a little bit of polishing and so on, and hopefully you'll find a lot of the techniques that we used here valuable and relevant to work that you might do with Power BI. One of the neat little tricks I mentioned earlier in this course, in the lesson on slicers versus filters, is the ability to create a slicer panel in Power BI. In situations where you have several slicers on your page, they can take up a lot of space and leave very little room for your visuals. Now, you could move your slicers onto the Filters panel, but as we discussed in that lesson, you'll lose some functionality if you use the filters instead of slicers. If you're looking for a way to keep the functionality and user experience advantages that slicers give you, but you don't want them to take up space on the page, well, slicer panels are coming to the rescue. Slicer panels use a feature in Power BI known as bookmarks. Similar to pages, bookmarks act as a navigational aid inside the Power BI report layer. With bookmarks, you can take whatever view you're currently looking at, whatever page you're looking at, and whatever filters you have applied to your data, and save it inside your report so you can return to that state later. That's why they call it a bookmark. It's a way to quickly navigate you to a part of the story in your data. Here's an example of a real-world report that I built for Davidson that uses bookmarks inside of a page. There are several pages in the report arranged along this left-hand navigator, but this particular page summarizes some details about Davidson College's student enrollment. There are 4 different views of this enrollment data that break down Davidson's student body by their statuses, some demographics, which U.S. states they come from, and which non-United States countries they come from. These 4 buttons in the top right are a bookmark navigator, very similar to the page navigator we used in week 2, and they allow the user to navigate between these 4 different views of the data without ever leaving the enrollment page. And the way these bookmarks do their job is by simply showing and hiding specific visuals on the enrollment page. If I click the breakdown bookmark, it will show me these 2 tables that summarize students by their statuses. But if I click on World Countries, those 2 tables become hidden and are replaced by this table and World Map and a couple of cards that summarize the number of students by their home countries. This illustrates one of the primary ways Power BI report authors use bookmarks to show and hide certain visuals, which can create this experience of navigating between different views inside of a page. You can also use bookmarks to navigate between different preset filter and slicer values. Taking our Week 2 report as an example, if we had wanted to create a preset view that focused on sub-Saharan African countries, all we would need to do is filter the data, either by using a filter card, a slicer, or by cross-highlighting with one of our visuals. Then you create a new bookmark and set the bookmark to that view. Then you can navigate to that view from anywhere in the report using a simple button click action. But the main trick I want to show you today is how to build a slicer panel, because this is widely used by Power BI developers who want to create the appearance of an expandable and collapsible panel of slicers in situations where they may not have enough room on the report canvas to include them all. To demonstrate this, we're back on the home page of our AdventureWorks sales dashboard. We're going to create a slicer panel on the left-hand side of this page that shows up when we click a button and hides itself when we click a different button. First, I'm going to move the logo and these slicers down a little bit on the page to make more room. Then I'm going to add my first button. Go to the Insert tab, find the Buttons menu, and select a blank button. This adds it to the upper left corner. I'm going to bring it down a couple of spaces and widen it. I'll right-click and go to the Format panel. Then I will open up the Button Style menu. With the default state enabled, we'll add some text, which we will call Menu. Change the font color to black. Then let's add an icon. Our icon type will be custom. Then click the Browse button. In your Week 3 exercise files, you will find 2 SVG images, one called edX PBI Menu Black and one called edX PBI Menu White. For the first button, we'll use the black icon. Keep the menu text aligned to the right-hand side, but then just crunch the button down a little bit so that it's closer to the icon. And feel free to tweak the text just a little bit to make it easier to see. Then let's add a little fill color with 100% transparency. But if we hover over the button, we'll give it a little gray color perhaps. Transparency to 50%. So now if I hover over the button, we get a little fill color on it. Perfect. Before we add an action to this button, we need to add a few more things to our page. To do this, I'm going to add a couple more panels to our view. I'm going to go over to our panel switcher, or pane switcher. I'm going to turn on the bookmarks panel and the selection panel. Then I'll close this, and we'll start with the selection panel. The selection panel gives you a list of every single object on your report page and tells you whether or not it is hidden, as you can see from these eyeball icons toward the right. Objects that appear towards the top of this list are higher up in the layer order, which means they are on top of the other objects. For example, if I take the logo and move it over on top of order year, we can see that order year is actually on top of the logo, because if we look at it in the selection panel, it's all the way down here, while our logo is actually at the bottom of the list. If we want to move the logo on top of the slicer, we have to bring it up in the list and drop it. And now the logo sits on top of the slicer. So that's how the selection panel works. And this is going to be very important in a few moments because it's going to determine how we arrange our objects on the page. The first thing I'm going to do is I'm going to go to the Shapes menu and I'm going to add a giant rectangle to this page. It's going to cover the entire page from corner to corner. And when I go to the Format settings, I'm going to make a few changes to how it's formatted. First of all, I'm going to turn off the border because we do not need it. Then I'm going to keep the fill enabled, but I'm going to turn it to a dark gray color, and I'm going to give it about, let's say, 90% transparency. That's way too transparent. Let's do 50%. The purpose of this rectangle is going to be to prevent users from clicking on any underlying objects in the report when the slicer panel is visible. It's basically going to act as a shield on top of those objects. Next, I'm going to add another rectangle, this time for our slicer panel. So go to the Shapes menu, select another rectangle, drop it on the surface, and then resize it so that it covers up the left-hand portion of the screen. Then let's give it a white color, remove the border, I guess, doesn't really matter, and that's really all we need to do. Now let's go to the selection panel, and we can see there are two shape objects at the top of our list. The first one, when we click on it, is our white slicer panel. The second one is the dark gray shield panel. Now what I'm going to do is I'm going to grab the slicers and I'm going to move these up in the layer order so that they sit on top of our slicer panel. So grab slicer 1, 2, and 3, and then click and drag them to the very top of the list. Now you can see that they are visible on top of that rectangle. Next, let's add our second button. We'll go to Buttons, create a blank button, put it at the top of the page in the same location as our other button. Then let's go to the Format settings. Let's start by adding an icon. Select Icon Type equals Custom. Then hit the Browse button. And this time I want you to select the edX PBI menu white icon. Make sure, of course, while you're doing this that the state is set to default and not one of the other states. Then go to Fill, select a color, and this time choose black. We're going to do a sort of positive-negative thing here, where the button on the slicer panel is black, but the button underneath the slicer panel is white. Let's give it some text, turn it on. We'll say Close Menu, make it bold, give it a white font color, Close Menu. Perfect. All right. Now let's grab our slicers. Let's move them up a little bit so that they are closer to the button. Now I think we are perfect. There's our slicer panel. I'm going to do one additional step here, which is I'm going to go to my selection panel and I'm going to grab all of these objects, button, slicer, 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 shape, and shape, and I'm going to group them. If you right click, there is an option to group objects on the page. So add these to a group. It's called Group 1, but I can double click to rename it, and I'm going to call this Slicer Panel. Now it's time to create our bookmarks. So we're going to go to the Bookmarks panel, and we're going to add our first bookmark. This one is going to be called Slicers Visible. Then we'll add another bookmark, which will be called Slicers Hidden. We'll go to our selection pane, and then find the group for the slicer panel, and turn its visibility to off. This will hide all of the objects in that panel group. Then we can go to our Bookmarks pane, find the Slicers Hidden bookmark, click the menu next to it, and then select the Update button. This will update that bookmark so that it uses this particular state, this view of the report that we are looking at right now. This will be the Slicers Hidden state. Now, if we go back to the selection panel, make the slicer panel visible again, then go back to Bookmarks, we can do the same thing on the Slicers Visible bookmark. go to the options, and click Update. Now, if we use the Bookmarks panel, we can toggle back and forth between slicers hidden and slicers visible. Slicers hidden, slicers visible. But there's one more thing we need to do. We need to get these buttons configured so that they will navigate to each particular bookmark. So we'll go to our first button that we have visible here. We'll go to the Format settings, open up the Action menu, turn it on, change the action type to Bookmark, and set the bookmark to Slicers Hidden. So this button will hide the slicer panel when clicked. Also, I'm going to do one more thing, which is I'm going to go to my on-hover settings for this button, and I'm going to change the fill color to a lighter gray so that when I hover over it, it changes colors like that. Perfect. Now, if I control-click on that button, it closes the slicer panel. Then we can go to our original button, open up its format settings, go to Action, turn it on, action type equals Bookmark, and Bookmark equals Slicers Visible. So now, if I control-click on this button, it opens up the Slicers panel. And if I control-click on this button, it hides the Slicers panel. Show, hide. Show, hide. Just like that. With these two bookmarks, all I'm doing is navigating back and forth between two different states of the report page. One with this group of objects hidden, and the other with this group of objects visible. This is very much the same as the enrollment report that I was showing you earlier, but actually a little bit simpler. So that's one very functional example of how you can use bookmarks in Power BI. Creating a slicer panel is a great way to give your users different methods for filtering the data with slicers while leaving lots of space on the report canvas for your visuals. The decomposition tree is one of my favorite visuals in Power BI because it creates an interactive way for you or your users to perform a root cause analysis of your data across multiple dimensions. It's an artificial intelligence visual, so you can do this analysis yourself, or you can lean on the AI to help you. If you give it a measure and a number of dimensions you want to analyze, you can then split the data across a sequence of dimensions from left to right, allowing you to trace the higher values and hopefully determine what's driving that measure. As I mentioned, you can do this yourself using the visual's interactive features, or you can ask the visual to employ its AI capabilities to analyze the data and chart a path for you. This makes it a powerful tool for ad hoc analysis and data exploration, and it can help you determine which stories in your data are the ones worth telling to your audience. For this example, we'll use our sales history data from AdventureWorks. I've created a fresh new report using the exact same data model as the one we created earlier this week. And you can see I've got a slicer along the top of my report canvas, which allows me to filter sales by the order year. I've also already added the decomposition tree visual from the Insert menu on the ribbon, and I've added our total sales measure to it. If we select the visual and look at its settings, we can see that we have three sections we can add data to: Analyze, Explain By, and Tooltips. We'll ignore tooltips for this lesson. The Analyze section will accept a single measure, and this can be either an implicit measure or an explicit one. In the Explain By section, we need to add our dimensional data, so we'll drop in some columns. We'll go to the employee table and add in the name. Then we'll go to Product. We'll add in category and subcategory and model. Then we'll go to Dim Reseller and add in the reseller name. And then we'll go to Dim Sales Territory and add in the sales territory region, and we can even add in the sales territory country. Now, when we did that, nothing happened to our visual except one tiny thing. There's a small plus symbol to the right of our data bar here. If we click that plus symbol, the visual gives us a pop-up menu with several options. We can see all of the dimensions that we added to our visual here, but we also see these two options at the top, labeled High Value and Low Value. These are called the AI splits. Choosing either of these options will engage this visual's artificial intelligence features to automatically find a sequential arrangement of our dimensions that best explains our total sales amount. So let's try it out with the High Value option. When we did that, the decomposition tree found the dimension that we provided that had the biggest share of the total sales, and it found the bikes category from our product dimension. Now, if we expand the bikes category and once again use the high value option, we can see the countries that the bikes category is primarily sold to. In this case, the United States makes up the vast majority of bike sales. We can expand this one further by clicking the plus symbol again to get the high value from the United States. And we can see that road bikes are the category leader, although mountain bikes and touring bikes aren't that far behind. We can expand this yet again, and we can continue to expand. Another thing to notice here is these light bulb icons at the top of the visual. If we hover over one of these, it will explain why it chose this particular dimension to expand. So notice how interactive and explorable this visual is. If I choose a different option in one of these columns, like mountain bikes, the downstream columns will update to display the relevant information for that subcategory. To clear a given column from the visual, we simply need to click the X next to the column name, like so. Or if we click the light bulb icon, that will turn off the AI split, and then we can click the column name to see other columns that we haven't yet used that we can swap out for this column. So in this case, I can swap the sales territory region for the reseller name. Another thing you can do is lock a column by hitting this little padlock icon that sits to the left of the column name. This anchors the column in place and prevents you or your users from changing it, which can be helpful for scenarios where you've determined that this particular column is vital for your analysis, and you want it to be in this exact position in the decomposition tree. So the AI split feature might help you get to the answers faster, but what I find really fun and interesting about the decomposition tree is the ability to customize the view. This makes for some really cool exploratory possibilities for you and your users. Overall, I think this is just a great visual. Super interactive, super easy to understand, and it includes embedded AI features that can help you find your answers faster. There are a lot of factors that can potentially influence test scores in students. Everything from your mother and father's educational achievements to what you had for breakfast the day of the test can play a positive or negative role in how well you score. So suppose you get a data set that contains test scores for 25,000 students. The minimum possible test score is 0, and the maximum is 100. Along with each person's test score, you get some attributes about them, including their sex, the highest level of educational degree their parents obtained, the number of students in their classroom, and whether or not the student participates in after-school tutoring. You are tasked with quickly identifying which of these attributes, if any, could be influencing student test scores. This is where the Key Influencers visual can be a big helper for you. Key Influencers is another AI-powered visual in Power BI. The AI analyzes the data you assign to it, ranks the various factors, and generates a visual that helps you explore these factors and how they affect the output. Let's take a look. We'll start by going to Get Data and then selecting Text or CSV. Then, in our Week 3 exercise files, you should find a CSV file named Test Scores. Go ahead and connect to that, and then don't bother with the Transform Data button. We'll actually load this data directly into our model. Once the data is loaded, let's go to the data view and take a look at it. In the data view, you can see the data and all of the columns that I described earlier. There are 25,000 rows in this data set, more than enough to hopefully find our key influencers. So let's go back to the report canvas, then go to our Insert tab, find the Key Influencers visual, and click to add it to the report canvas. Let's resize it, and now we can start adding data. Similar to our decomposition tree visual, you can see that we have 3 possible areas we can add data to: Analyze, Explain By, and this time, instead of Tooltips, we have Expand By. I'm going to add our test score column to the Analyze section, and then under Explain By, we'll add After School Tutoring, Parental Education, Sex, and Classroom Size. As you add dimensions to the Key Influencers visual, it will start to automatically analyze the data and look for which influencers it thinks are most relevant. In particular, it's highlighted for you that after-school tutoring seems to be a large factor in higher test scores. The visual asks us, what influences test score to increase? And it answers, when after-school tutoring is yes, the average test score increases by 14 points. When parental education level is doctorate, the average test score increases by 7 points. And there's a chart that shows us the effect of each different educational degree level on test scores. We can also see that classroom size seems to be a pretty big factor. When classrooms consist of 16 or fewer students, the average test score goes up by 5 points, presumably because fewer students in the classroom means the teacher is able to give more individualized attention to the questions and the issues that students are having when they're learning their lessons. We can also choose from this drop-down menu to ask what influences test scores to decrease. If we do that, the key influencers visual will reanalyze the data, and honestly we just get an answer that looks like the inverse of what we already saw. The other section to point out here though is the top segment section. If we return to increase and then go to top segments, it asks us when is test score more likely to be high? And what this is doing here is it's grabbing our population of 25,000 students and it's breaking it down into different segments. Segment 1, for instance, has an average test score of 88.54 and consists of over 2,400 students. This particular segment consists of students who are engaging in after-school tutoring and who have at least one parent with an educational level of doctorate. This seems to be generating an average test score about 12.28 points higher than the overall average, which is 76.26 points. We can go between these different segments to look at other attributes that the Key Influencers visual has highlighted. Key Influencers is a great tool for exploring possible relationships in your data, seeing how a particular outcome might be driven by some of the dimensions that we see. Be careful with this visual though, as you should be aware, correlation does not imply causation. As much as cereal companies might like us to believe it, it is not true that eating their sugary cereal before your basketball game is going to result in you hitting that game-winning three-pointer at the buzzer. And it's also not true that getting a tutor will automatically result in a higher test score according to our data. It's just one potential factor that can influence a test score, but don't make the mistake of thinking that the relationship is automatic. The way I like to use key influencers in Power BI is as part of my early analysis of a dataset. If I'm being asked to find which factors in the data might influence a particular outcome, I might add the key influencers visual and see what results it gives me. For example, if I was building a full report based on this data and the key influencers visual indicated a strong relationship between classroom sizes and higher test scores, I would explore those factors a bit more using statistics to make sure that I'm confident in what the data is telling me, and then find a good way to visualize that data, such as by using a scatter chart, heat map, or some other kind of visualization. That work is what will ultimately end up in the final report. But I don't think it's a good idea to put the key influencers visual in front of end users unless you educate them about it first and make sure that they know not to confuse correlation with causation. Otherwise, they could end up clicking around this thing without really knowing what they're doing, and they could come to the wrong conclusion. Remember that your job as a data analyst is to dive deeper into these kinds of questions and separate the signal from the noise, and then present that signal to your audience. The key influencers visual is a good tool to help you with that. If you're curious where this data came from, the answer is nowhere. It's 100% fake data. I created it from thin air by writing a script in the Python programming language to generate a bunch of random data, but I weighted the test scores for some parts of the population so the key influencers visual would be able to work its magic. Then I pasted the script into Power BI, and it produced the data that you're using, which I then downloaded into the CSV file. I've included the script below this video so you can try it out for yourself. You just need to make sure you have Python installed on your computer and that it's set up inside of your Power BI desktop settings. I'll include links below to help you out if you're interested in exploring these options. In week 3, we've introduced you to the concept of the star schema, which is a hugely important topic in the world of Power BI, and which you'll probably encounter on the Data Analyst Certification exam if you take it. For the final exercise of week 3, we are still going to build a report, but this time I don't really care what it looks like. The main focus of this exercise will be on data preparation and modeling using Power Query. We're going to build a star schema from a single large table of data, which might be harder than it sounds. This exercise will require you to look carefully and critically at the sample data set, particularly the attributes of the data and where they belong inside of a star schema. You'll be asked to answer some simple quiz questions after that. The data comes to us from the city of Houston, Texas, here in the United States. The city government has an open data portal where they publish CSV files of their yearly budget and payroll data. I've downloaded two of these files, one for the 2023 budget data and one for the 2022 budget data. The main reason you might find this exercise challenging is that you'll need to think for yourself about how to combine the files in Power Query and how to successfully break them out into a star schema. This is not only going to require you to recall this week's lessons about star schemas, but also will require you to reach back into week 2's lessons about referencing and duplicating queries. If you do it right, you should come out the other end of Power Query with a well-optimized star schema that is ideal for building reports inside Power BI. But note that there may also be some gaps in the learning where you'll be required to figure out a solution yourself using the tools that are available on your ribbon in Power Query. You'll need to study the granularity of the tables you're creating and think about what operations you'll need to perform on the data to successfully restructure it. The only hint I will give you is this: watch out for duplicated data. Okay, good luck with the exercise. The goal of the Week 3 final exercise is to end up with a star schema data model that looks like this, with 5 dimension tables arranged around a single fact table. Let's walk through how to do this in Power Query. First, connecting to the 4 budget files. You have 2 options for how to do this. The first option is to create one CSV query for each file and then append them all together using the methods I've taught you. Or you can take the quick and lazy approach, which is to use the folder option in your Get Data window. When you hit Connect, you simply need to provide Power Query with the folder where the files are situated, and it will combine the files for you automatically. In this case, if you open up the Week 3 exercise files and select the Houston subfolder, and then click OK, Power Query will do all of that work for you. If you discovered this option and used it with the Houston folder, you're already ahead of the curve. Then just hit Combine and Transform Data. If you take that approach, you should end up with a single query called Houston, and you'll have these helper queries here, which you can collapse because you don't really need them. The Houston query is a single big table, what I sometimes refer to as a monolithic table, but we need to decompose this into a star schema. That requires us to identify each entity in our business process that needs to be stored in a dimension or a fact table. The first and most obvious is the fiscal year. We will want a separate table for that. Then we have these 3 fund columns, which consist of a fund ID, a fund name, and a fund type. Next, we have these department columns, which also have an ID, name, and type. Then there are these GL columns. GL stands for General Ledger, which is a very common term in financial accounting, which refers to the numbered accounts that we use to categorize and track transactions. Again, we have a numeric column, followed by a description, and then a category that seems to have a parent-child relationship with the description, so each account rolls up under a particular category. Lastly, we have this revenue or expenditure column. These are our 5 dimensions. Everything else in this table is fact data. So now that we've identified our dimension data versus our fact data, let's begin breaking this down. First of all, I'm going to deactivate the query and rename it as source. Then I'm going to use our reference feature repeatedly to pull out each set of columns from the source query into a new query and make some transformations. Now, an extra thing that you'll see me doing here that you probably didn't do is you'll see me adding index columns to some of my dimension tables. These are known as surrogate keys. Surrogate keys are unique identifiers that do not originate from the source data, but instead are created afterward when the data has been copied to another environment. Developers add surrogate keys in dimensional modeling scenarios in order to create relationships between tables and enforce referential integrity. Now, adding these index columns to your model is not necessary for this particular exercise because our dimensions already have these numeric ID columns here and here as an example. These are known as natural keys, but I'm showing you this technique to create surrogate keys so you can be aware of how to do it. In a situation where you did not have these ID columns, it would be enormously beneficial to add surrogate keys like I'm doing. I'll provide some additional reading about this below the video. So we've already copied the query once, so I'm going to go ahead and double click and rename it as dim fiscal year. Then I'm going to select our fiscal year column, right click, and say remove other columns, then right click again, and remove duplicates. That's all I need to do for dim fiscal year. So I'm going to go back to source, right-click, and reference. And this query will be called dim fund. I'm going to select fund ID, fund name, and fund type, right-click, and remove other columns. Then I'm going to select all my columns, right-click, and remove duplicates. Then I will select my fund ID column and sort in ascending order. Finally, I'll add my index column. I'll go to the Add Column tab, find the index column feature, tell it to start from 1. I'll rename this new column as Fund Key, and then I will click and drag it to the start of my table. All right, let's go back to source, right-click and reference again. This time, we're creating dim department. So select our 3 department columns, right-click and remove other columns. Then let's select them again, right-click and remove duplicates. Sort the department ID in ascending order, and then go to Add Column, index column from 1. Once it's created, rename it to Department Key, and then move it to the left-hand side of the table. That's another one down. So let's go to Source, right-click, and Reference. Rename this one as Dim Account. Scroll to the right, grab our 3 GL columns right here, right-click and remove other columns. Right-click all 3 again and remove duplicates. Then order the GL account in ascending order, and then create our index column. From 1, index is created, call it account key, and then I'm going to reorder the columns one more time to put account key and GL account at the start of the table. Next one, we'll right-click and reference. We will call this one dim type for our type dimension. We'll find our revenue or expenditure column, right-click, remove other columns, right-click again, remove duplicates, then index column from 1, and we will call this type key. Move it to the start of the table, and now we're done with that. Finally, we have to create our fact table. So I'll go back to the source, right-click, and reference one more time, and we will call this one fact budget. To get our surrogate keys added to our fact table, we need to merge all of the tables that we just created into fact budget. So I'm going to go through and one by one merge all of those queries in. So I'll go to Home, Merge Queries, select the dim fund table, then select fund ID from both tables. Make sure that you get 100% match on the bottom of the window, then click OK. Then let's do the next merge. This time we'll merge on the department ID, so select dim department, department ID to department ID, 100% match, click OK. Next merge. This time we're going to select GL account, go to dim account, GL account to GL account, 100% match, click OK. And then lastly, go to merge queries, revenue or expenditure, dim type, revenue or expenditure. We get 100% match with a left outer join and click OK. Now we can remove unneeded columns, which is going to be pretty much everything except for the amount columns at the very end of the table. So select all of these, fund ID and source name. Do not select fiscal year, then right-click and remove columns. Now we can go through and expand each of these tables. Dim fund, expand and select the fund key. Dim department, expand and select department key. Dim account, expand and select account key. And dim type, expand and select the type key. Now I'm going to grab these key columns, all 4 of them, and drag them over to the start of the table after the fiscal year column. And now we have columns that can link to, in order, dim fiscal year, dim type, dim account, dim department, and dim fund. And then we have our fact data, current amounts, adopted amounts, and actuals amounts. At this point, we're ready to go. Click Close and Apply, and let's load our model into Power BI Desktop. And there you have it. That's how you can build a perfect star schema created from a single monolithic table of data. Decomposing one of these big tables into a star schema will improve your report performance and the quality of your reporting, and it will logically organize your data to make it easier to understand. This is a great data preparation and modeling pattern to learn in Power Query because I can almost guarantee that you will encounter it multiple times as a data analyst or developer. Well, that's it for week 3 of our course on Power BI. This one was intense. We dove headlong into the world of using Power BI against relational databases, tackling such mind-bending topics as query folding and how to add parameters to your reports. We also got to explore time intelligence functions in DAX, which are incredibly powerful for analyzing time series data like our sales data, and we learned some creative new styles of visualization, including a few new AI visuals. You'll be relieved, probably, to hear that week 4 won't be as demanding as weeks 2 and 3 were. You're close to the finish line, so we're going to turn our focus to some data visualization best practices that you should be aware of, maybe a little bit of exposure to the Power BI cloud, and then we'll cover some additional learning opportunities beyond this course that you may want to look into. But before we get to those, we'll also give you the final capstone project to complete that will ask you to employ many of the skills that you've learned throughout this entire course. So, take a break, give yourself a pat on the back for your hard work, and get ready to meet me in week 4 for the culmination of our course, Analyzing and Visualizing Data in Power BI.